So everything big happened. Before everything big happened, always something happened, right? Every time, always like this. So here I give. It's very happy to come here to give the speech about Open UR. The topic is Open UR bringing new opportunities to the diversified computing era. So I'm Wei Xiong. I'm the member of the technical committee of the Open UR community. Okay, so the first question is, when we talk about the Open UR, maybe somebody say, okay, is kind of another boring OS distribution? The answer is no. So let's clarify what's the problem we try to resolve. Personally, I think there are three tough challenges for the OS industry. The first one is the fast development of chipset bring tough challenges for the OS development. I think the chipset has been very booming in recent 3 or 4 years. And in the future, we can forecast that there are more and more new type kind of chipset will appear. So the second one is the OS need a more aggressive innovation to bring things to be lighter and faster. So personally, I think nowadays the OS, especially for the Linux system, it become bigger and bigger and heavier and heavier. So our idea is how to reduce it and reduce the size, to make it lighter and faster. And the last problem, I think, is the gap between the server card and the embedded system, because the Linux system is divided to be server and embedded system. There are two worlds that they don't link very well. So that's another kind of challenges. So what's the Open UR's way to resolve? I think one word is okay, aggressive. So we will do some aggressive innovation or modification to resolve this kind of challenges. Okay, so I think Linux has been the most successful OS during the last several decades, and it can spread from the server cloud to the edge computing to the embedded system. It has been very successful in industry, but everything looks fine. But is it perfect? Is it so perfect? I think it's still a question for us. So first one is the chipset, challenging chipset. You know, OS always can work with the chipset. If you look back to the chipset development in maybe 5 or 10 years before, the chipset evolved very slowly. You just take care of Intel's chipset is enough. But more and more chipset has been appeared in recent years. So suppose you are a chipset vendor, what kind of situation you will face? It's very easy to understand. You tape out the chipset and you put the feature to the upstream kernel, and the upstream kernel, maybe it's not easy. Maybe spend half and 1 year to do that. And if the upstream kernel accepts the feature, and then the OS vendor will take the feature down and build the OS, and then this may also spend another half year and push the OS to the customer, maybe spend another 1 year, maybe to be mature. So it takes around 1.5 and 2 years. But a chipset, generally speaking, a chipset has 3-year life cycle. So that means half of the life cycle, chipset life cycle, will be spent to do this kind of job. The customer cannot access them. And consider the kernel evolved very quickly, 4, 5, 6, and 4.1, 4.2, 5.1, 5.2. And also the OS vendor also has a lot of kind of distribution. So they also exist a lot of OS vendors, right? So that is also a problem between the chipset vendor and the OS vendors. And in addition, we consider more and more chipset type. If everything is x86, it's fine. It's fine. It's not so complicated. But now, more and more ARM architecture has came into the market, especially for the server and the cloud. So more and more company will adopt the ARM server to use, right? And additional, a very shining star with 5 appears. And especially for in China, I guess there are maybe 50 company, kind of company, not big, small or medium company. They produce a lot of kind of refined chipset outside tape out. So when we consider all of those things, the OS and the chipset were a big mess. It's very complicated. So how can we handle this in some degree? So OpenUI will have adopted this kind of way. We will have the release. It's a normal way, right? We release a version 2 times per year. One is in the March, another in the September. So in this number, those release, we call the innovation release. You can put everything immature and blood bleeding features into those kind of release. You can make a try. We provide some environment to do the verification job. And then per 2 year, we will release LTS, long-term service version, which can help the company. We will make sure the quality, and we will maintain the LTS for 6 years to ensure the company will adopt mature product. So that is the way. So our way is, if you want to try something new, to verify some chipset, you can go very early to the innovation version cycle, and you do the verification and go back to LTS version. And so we will adopt more aggressive release cycle to meet the aggressive chipset development. And secondly, for the new architecture, especially for the ARM and RISC-V, we will adopt very aggressive strategy to adopt these new features. So, a new feature, especially for some big feature, it's not easy or spend a very long time for the upstream, for example, kernel, glibc to accept the feature. But for OpenUI, we open the door to those kind of feature to promote the usage of the new architecture. And then we have another very important feature is we share the same code base. In this point, we have released 2 LTS. For the second LTS, which is the 22.03, this is a very milestone version. In this version, no matter what the chipset you use, x86, ARM 645, they share the same code base. That means one code pool to create 3 kind of versions. So if you are a developer, you just keep to use the API. They share the same API. If you are a device producer, the driver will face the same kernel version. So we will maybe reduce the gap between the usage of the new architecture. Okay, so that's the general information how we handle the chipset issue, but it looks not so aggressive, right? As a regular way. Okay, let's move on. If we just consider the general CPU as consider, it has been very complicated, but more complicated is coming because we have more and more GPU, DPU, TPU, or XPU, a lot of kind of PU. So for this kind of PU, how to handle them? And they evolve very, very quickly. For example, the DPU in China, I guess there are over 10 companies, startup company to do the DPU, very different, a very different SDK. And also, for a very complicated OS, every week we can receive over 40 CVE issues, vulnerable issues, how to handle them. And then OS release, you have to always update the kernel, update the OS in the cloud if you have millions of machines in the cloud. So they all need to make the kernel to be more flexible, cannot be fixed. So if we consider kernel is the interface between hardware and the user space and the developer. It's a very traditional way for us to do that. But the problem is why we cannot handle the chipset evolvement and so many new chipset type. The root cause is kernel is highly coupled and unchangeable. Unchangeable doesn't mean you cannot adjust it. You just can put some parameter into the kernel to do some justify, but it's very, very slight. It cannot change a lot of things. So generally speaking, when you change something in kernel, you have to compile it to be a new kernel and then deploy it again in cloud. So that means changing anything means change everything. So that is the problem we have faced. So here we have a new idea. So is it possible to make those kind of key components of the kernel to be more modularized? So for example, we know nowadays the kernel will adopt the eBPF mechanism. eBPF is very good, but it's only used in the network in the beginning. Now expanded to more area, but most of the usage is still limited into the network. But it's a very good mechanism because you can make some policy in your space and compile it and inject into the kernel, and the kernel will run those kind of policy to do that. So it's a perfect design. That means the policy is divided from the framework. So framework is framework, policy is policy. Framework is only to load the policy to run it. So we can borrow those ideas. Is it possible if we can modify or redesign the kernel to follow this way? So that means the kernel only to run the framework, but we can make a different kind of policy in the user space and compile it and inject into the kernel to let kernel to always flexible. You can change something. Another way is in the left of the PPT slide, you can see the driver. In this system, especially for the kernel, we have a lot of kind of drivers. Driver is very complicated and not easy to migrate. But is it possible for us to make a new driver framework? That means you can write the driver once, but it can run in different kind of this kernel version. So that is also kind of an idea. If we can finish these two kind of steps, that means we can handle some difficulties we are facing. So that is the framework we are doing. We call it a kernel as a service. We call it CAS. So the first photo step, I suppose we can release the first prototype by the end of this year. So welcome to came to Open User to see it in this year. Okay, so the idea you can see our idea is to make the kernel to be more lightweight and a streamlined kernel. But OS is not only kernel. They have a lot of things. For example, the virtual machine level and the container level, right? The kernel, virtualization, and the container, the three levels. The same idea, we think Docker is too big, too thick. And also we think the QML is too big, too thick. They get together and everything in the same image. So we developed two projects. One is for the threat word, which is to try to replace the QML system. And also we developed the Isla. Isla is also to replace the kernel, the Docker. So it's very slight. It's only maybe 10% the size of the QML or the Docker. For example, the threat word is only, I guess, 4 megabytes. It's very small and very fast. So it can be deployed from the cloud to the server, to the edge, even to the embedded. So embedded system also can enjoy the virtualization work and the container work. So that is the idea. And also, besides this kind of the structured component, key component of the OS, we also want to do some aggressive changes. We want to modify the number one process. Number one process we all know that is the system D, right? It's very big. So also we develop a new project which is called SysMaster. It uses Rust to rewrite process one to make it lighter and safer. Because if you get used to the QML or the systemd, you will find always have some CVE problem, always affected by the bugs. So we also for the server, we also use the Rust language to write the program. So we have done so many things, and also all of the project we want to make the things lighter and maybe faster. But it's only for this? No, we have bigger vision. So that means a universal OS platform. Because somebody will challenge that universal is a too big word, right? Okay, let's explain what it means universal, right? Actually, if you check our industry, you will find that there is a very clear line between the server side and the embedded side. For the kernel side, we often use the CentOS, SUSE, or Ubuntu. In the embedded system, you always use the WinRiver, Linux, or the Yocto system, right? But unfortunately, the two systems are totally unlinked. They share the different architecture. They share the different. They share nothing. They don't have the same code base, and if you use it, it's not totally different. And when you build a system, you want to do the CI/CD. The server side will use Koji or OBS, but for the embedded system, always use the Yocto. That's totally different. But everything should be connected. Not should. Is doing the connection around the devices and the devices to the edge computing and connect with the cloud. So everything of the system will connect together. So in theory, the ideal world is everything should share the same thing. And the application can run smoothly from the cloud to edge to embedded. And if I'm a chipset vendor, I just need to work with one group, and they can make it the embedded edge and the cloud or server. They share the same thing. I don't need to work compliance with this vendor, that vendor, this OS or that OS. It's very tedious and consume a lot of effort and money. So is it possible to do that? Okay, so let's consider what is OS. No matter it's embedded or edge or server or cloud, actually OS is a collection of packages or components. So no matter you use as an embedded or a server, you share the kernel, right? Kernel is one of the packages, right? So we came up to an idea. So can we make the component to be component? And then if we want to do some OS, we can use some language or some config file. For example, the YAML file is very easy to understand, very easy to run, and just give the system a YAML file to describe what kind of OS I want. And then the component system will produce the OS, what I want. So in China, we call it tenant and socket structure. It's a kind of structure used by the Chinese traditional building. It's the component is very similar, but you can use very similar component to form very huge building and also very small building. But internally, it's similar. So we build a system which is called OLA Maker, but of course it's still under the development. Also, in the middle of this year, we can release it maybe the alpha version, or call it a 1.0 version. It can reach the requirement that we have a very big component pool. We share the same code base, no matter it's x86 or ARM64 or RISC-V. They share the same. And then we provide a OLA maker composer system. And you can put some description or requirement for the OS to the OLA maker, and the OLA maker will produce this OS for you. So OLA or OLA OpenUI is not a OS. It's not an OS. It's an OS platform which build different OS. So that is the, I think, a more accurate definition of OpenUI. Okay, so let's do a small summarize. So we optimize the OS component for lighter and modular because we want those components can be deployed in cloud and to the devices. So we need to make every component to be smaller. And also we can use those components to reorganize to be different kind of OS. So that is to meet the different scenarios. So that is the idea. Okay, when we talk about it, we replace a lot of things, but it doesn't mean we abandon the old ones. So for the Docker, for the Keynote, it's still in our package pool. So you can use it to compose the system. So we have just provide a second choice. Okay, I have told. But I came to the end of the speech. More than that, we have developed a lot of new things. You can come to the website to see that. For example, Attune, AI-based performance tuning tool. You can do the performance tuning by AI. You use this kind of tool. You can have the kernel hot replacement, which can enhance the cloud ops technology, and we have Bishing JDK, which is optimized for the ARM64 and the RISC-V. And also we have NFS Plus. We reorganized the protocol of NFS. NFS is very popular, right? But it's not fast, it's not robust, and not stable. So we redesigned the protocol to enhance and up to 6 times speed and more robust. And we have KeyMesh, Gazelle, and AI Ops. AI to use AI technology to do the DevOps. So until now in OpenUI, we have around over 300 kind of new projects. So if you can go to our website to find those kind of components, of course, you can use the component to other platforms, for example, Red Hat or Ubuntu. Okay, so here is the, I don't read the number right? It's very big. At least in China, it has to grow very, very big. Size, and we have accumulated a lot of developers, and we have accumulated a lot of organizations and companies. Okay, finally, so it's the end of the speech as a very quick introduction of OpenUI. So here is the website. Of course, some of the material content is still written in Chinese, but if you find some this kind of issue, can report the issue to help us to improve the project. Here is the website, but before after the website, you still have the project. We have Git repo. Over here, how to engage. So you can take the picture, and we can communicate in those channels. Okay, everything is new, so we try to bring some new things to the old OS industry. So welcome to join OpenUI to enjoy the new world of the year. Okay, thank you.
All right. Thank you very much, Wei-Xiong. Unfortunately, we don't have time for questions because we're running out a bit of time.
Okay.
But you guys can find them in the booth area, right?
Yeah.
Yeah, they guys have a very nice booth down there. So please, if you have any questions, come by and ask them later. Yeah. Thank you.
Okay, I will stay in tomorrow. I will leave here because I have another meeting, right?
Okay.
Tomorrow and the day after tomorrow, I will stay here. Okay, nice to meet you.
All right, so you can find him tomorrow in the booth? Yeah, all right. Yeah, thank you very much. And next we have our panel. I think Hongfu is going to come over. Yeah. So we're going to set up the chairs for the panel.
Will be facilitating the conversation today. Today with me, I have four wonderful speakers, come from very different backgrounds. We're going to share about their experience and their insights on this topic. So before we begin, I would like to just do a very quick introduction to all the panelists. Yeah. So on the left-hand side right here, I have Dr. Lim Tich Mang. He is the president of the Singapore Association for the Advancement of Science, the president of the Singapore National Academy of Science, the member of the Singapore Bioethics Advisory Committee, a former board member of the Association of Science and Technology Centers, and the president of the Asian Pacific Science Centers Network. Welcome, Dr. Tich Mang. This is not the first time you are here. You are a regular speaker at FOSSASIA, and you supported in the past as well with the Science Center. Thank you very much for being here.
Thank you. Thank you for inviting me.
Welcome. And next, I have Sinhu Chankar from Microsoft. She is heading the Azure business for SAP, Digital and App Innovation, and Azure Hybrid for Microsoft's Asia Pacific region. She's been already 8 years with Microsoft. She is responsible for defining the GTM strategy to deliver customer and partner success and for revenue growth of the businesses. Sinhu, once again, welcome to FOSSASIA Summit.
Thank you so much for having me here. Glad to be here again after 5 years.
4 years. Yeah, but it feels lovely. It's 5 years. Yes, and next I have here Kiwi Tang. He's not only a friend of mine, but also one of the previous organizer of the FOSSASIA Summit. So Kiwi at the moment leading, he is the CEO of a local hardware production company called Lions Force. This company actually produce laser cutter. Yeah, so if you're not aware that people talk about Singapore, we are very famous for shopping mall, a lot of services industry, but we actually produce something here locally, and we will talk more about it later. Previous to his company, he actually a fighter aircrew for the Singapore Air Force for many years. Yes, and as mentioned already, Kiwi used to be in the organization of the FOSSASIA Summit previously. Welcome, Kiwi. Welcome back.
Thank you. Thank you.
Last but not least, very excited to meet Cheryl Tukup. This is your first time here at the summit, Cheryl?
First time at Summit, yeah?
Yes, so Cheryl is the Regional Director, Marketing for Asia Pacific at Rafana Labs. She recently established a marketing team for Rafana, originally from the Philippines, but Cheryl been here for over 16 years now and over 20 years of experience in the IT industry. Very happy to have you here. Thank you for joining us.
Thank you for having me.
Okay, so let's going on to our first question. So I have a few questions prepared for the panelists before we open up to the audience. So my first question is actually, I only did a very brief introduction. I want to understand and would like you to share with the audience what inspired you to pursue a career in science and technology, and how did you get started? So how about...
Yeah, sure, I'll start.
Yes, sure. Would you like to start?
Last, I might as well start, you know? Hi, everyone. Good afternoon. I hope everyone's having a good time. Yeah? Yeah. That's a woo! Sorry, I'm in marketing. I need to do it. I started in tech really oddly. I'm actually, I think one of the things that I put in my bio is that I actually graduated with a finance degree. Major in banking. So I should be in a bank right now, right? But I graduated in 2000, and anyone here who graduated in 2000, don't be shy, it's okay. That was a dot-com boom, right? So everyone's talking about the tech, the dot-com, and whatever. I was thinking, I want to be there, right? So instead of going to a bank, sitting there and talking to clients and getting them to open an account, I decided to go to tech, right? That's basically it. Yeah, and then never look back. Yeah.
Well, since you passed the mic to me, I was hoping that you'll go that way. You talk about graduating in the year 2000. Yeah. Who were born in 1960? Okay, right. Hopefully you know that I'm not a so-called IT person. Okay, I'm a biologist. And I always loved science and nature since I was a little kid. I can claim the status of being the first honors year's thesis using computer simulation. At the time, I'm always very curious, so I'm a learner. By nature, I'm a learner. I'm still learning. That's the reason why I come here to learn whenever I can. I remember when I was doing my honors year's thesis, I was introduced to programming language called BASIC. I mean, it's way ancient to many of you. And it was so basic that it's no more in existence now. But I learned how to do programming, and I think that was the first thesis ever in the NUS, the department. Without touching any single animal, I did a project simulating sampling of animals in the field, and using that to calculate so-called impact. That meaning you can compare this community and this community, what's the difference? And at the time when I presented it, the professors, they all didn't understand what I was talking about. I heard the professor saying, let's give him the benefit of doubt and give him a good grade. But my professor was telling me, let's try and see whether the field out there believe in what we came up with. And I was very happy that the paper was accepted in a journal. And now that I'm in NUS, and they all talk about ranking of your journal, at that time it was considered top-class journal. So that was my first foray into using IT, and that's the reason why I believe in tech. And when it came to Science Center to ask whether we could support you for FOSSASIA, I saw that it is a very meaningful proposition, and I'm very happy that you have grown to this stage now. Every year you are back, every year it becomes stronger and bigger. So thank you very much. So that's my journey. It's out of curiosity that I continue to stay in the science and tech environment.
Curiosity, yeah. And then, Sinhu, before we go to the next question, would you like to go next?
Okay, sure. So when I was thinking about my options, in 2000 is when I graduated as well. Tech is where the money and the opportunities were. And so many years later, that's still where the money is. Right. So fast forward all this time, I've still been in tech. I started off my first job in Dell because my degree, my undergrad was in computer hardware. I didn't want to do what everybody else was doing, which was software. So I said, okay, I'm going to do something different. And I went the hardware route. But nevertheless, I did a part-time software course. And then eventually, so I started my first job with Dell in hardware. And then I did move on to do my MBA a year later. Because I always thought I wanted to get into the business side of things. And guess what? Even after my MBA, on day 0, when all of the companies were coming to campus for hiring, the tech companies were ones taking the slots, right? The day 0 slots. Not the consulting companies, not the finance companies, but it was the tech companies taking the day 0 slots. And that's how I landed my second job in another tech company, but this time in services. So I landed up in the IT services industry, one of the global players in that space. And so I've never looked back again. I've been moving continents, I've moved countries, but eventually I've continued staying in the tech industry. So that's where it is.
Yeah, so you and Kiwi have something in common. Also, he also into hardware. How about you, Kiwi?
Okay, so I think the story go back to about 2015. Then I was still a major in the flying F-16 in Air Force. So what happened here then at 2015 is that the government is promoting innovation and entrepreneurship. I think that's where the Smart Nation initiative was rolled out. So at the back of my mind, I totally believe in this movement, at least for Singapore, coming from a very kind of like patriotic kind of feeling. But one thing that I've seen is that the manufacturing ecosystem in Singapore already more or less is reaching its tail end of the decline. I decided that so I imagine that how can an average Singaporean come out using open source or whatever resource they have back then to really enterprise and create a product that's made in Singapore. So that took me on a journey from 2015 to 2017, where I do a lot of open source projects. And in fact, that's the only resource that I can find. And that is how actually I met Hong Fook in one of the Science Hack Day. That's how I kind of joined FOSSASIA. Then in 2017, as I kind of mentoring Singapore students, is that, okay, you need to innovate, you need to enterprise, but now you're having a secure job, and now you're telling people to take risks. It doesn't make sense. So I need to lead by example. So I quit my job, decided to start a company called Lions Forge, and then using same thing. I have no engineering background, but just using pure whatever I can learn from the community, and then develop a product that can compete on the global stage. And then with that lesson, I'll just pass down to all the young folks here, whoever willing to listen to me.
Yeah, and you took part in a lot of Makers Fair. That's how we got to know one another. Again, very happy to see you growing from strength to strength. I walked downstairs and saw your booth downstairs. Indeed, Lion Forge is doing very well. Thank you.
Thank you. Yeah, feel free to come down, see the booth, and then see what we can build with open source, right?
Yeah, so I find really inspiring to hear the story. Like for some of us, did not start in the tech major, but we all ended up here in tech. And can we mention something that I want to, actually the main question that I have here today, which is related to open source. how important is having experience in open source projects for getting hired in the tech industry? We are at the open source conference, and what is your opinions on this? Kiwi, do you want to talk? You mentioned already that you want to show the potential of open source to younger students in Singapore.
The context is slightly a bit different because here you are talking about how to get a job, right? So for me, it's more on how to be an entrepreneur. Even if you do not have any kind of background, it's just that the wealth of knowledge and resources in the open source community or the world, or I would say the open source universe, it has grown really like strength to strength. It is amazing. I couldn't imagine, like, let's say back in the 1990s, let's say when I started in Poly, if I were to do the exact same thing that I want to do, it's impossible. Not without open source. So in a way, just now, as if you guys have listened to the few of the lectures, right, it's like you can see that the technology refresh rate and enhance rate is so fast, it's so rapid. Trust me, no education system can support that. So you want to keep yourself up to speed, you need to be part of the open source community to keep up.
I'd like to add on to that. What Kiwi said is open source by its definition is open for access, is democratizing the tools, so to speak. And in the Science Center field, we also look into open source. And I also encourage our people here, especially young ones, to get into that. Because through open source, you get into the opportunity to co-create many things. And in the Science Center, there are many things that can be co-created because of open source. And in the format of including even making very immersive kind of omni-theater system. Because now, with a lot of data coming in, you can actually pull out data from NASA, you can pull out data from Google Earth, and using open source, you can stitch together and narrate a program. And you can also share with the community who can create those. Recently, we just created one that is bringing you from Earth all the way out to the edge of the universe and come back to Earth again. And that is because the open source platform. Yeah.
Now, I can probably attest to that as well. Open source is about creating an open mindset. So it's all about collaborating and making sure that you're sharing so that others can benefit. You build on the value creation and let others use it. So today, if you think about, like, even a statistic, about 90% of enterprises are using open source in some way or another. So there's no running away from open source. And even large enterprises like Microsoft use as well as contribute a lot to GitHub. They contribute reuse code from GitHub. So it's a lot of open source that's being used across. So yes, to hiring, I would think yes, but definitely will be a useful skill to have.
Yeah, and to me, it's more really, it's in everything that was said. Is really, I just want to reiterate that fact that it's a lifestyle now. You know, kids, they Google something, they only go for the free ones. It's technically open source, you know. It's inevitable, and most big tech companies that are technically legacy, like, okay, I'll mention the one that I came from, F5, right? Are investing in open source, acquiring companies like Nginx, IBM, Red Hat, right? It is a lifestyle, it is the way to go. So if you want to advance, you will inevitably get to an open source journey anyway, to be able to actually advance your career. You know, I think it's just the way it is.
Yes. So Cheryl, since you have the mic, I want to continue with you. So you mentioned that you were in finance and then later on moved into tech, right? So we regularly receive questions from people in the community how I can get into tech if I did not have a major in computer science or technology. And the next question that I have for you, and also perhaps Sinhu, you mentioned that when you get into tech because of the money, right? So people here, we have very young audience also from online. They all want to get a job like with corporation, well-known companies, right? And it's also even more important in Asia. You know that we all need to find a job to support our family and a lot of like challenges these days in the society. So the question is, what are the most important qualities employers look for candidates in applying for tech position. So especially, for instance, you can give an example from Grafana or Microsoft. What kind of qualities?
Well, so I'm in marketing. So I recently just hired someone in India. My first marketing manager there. I have one in Australia too. And for Grafana, because we are a startup in APAC, we only started a year and a half ago, right? So I don't have the luxury of the big tech, get an agency, do everything. No, we have to. I'm a director, but I also take the pull-up banners. Mario saw me yesterday. I was the one pulling up the banners. I was carrying luggages, right? And yeah, and to me, what I look for a person is resilience. You know, a person has to be able to do the strategy part, also the tactical part, and the hands-on part. That is, at least from a startup perspective, because that's my forte, at least from my perspective, right? So yeah, I think that's really what's important. And that relates back not only for tech, that's for, I think, the current career opportunities anywhere in the world right now. Yeah.
So what you say, people need to say yes, start doing things.
Yeah, you have to be able, you have to be willing to learn new things and to be able to actually do it. Like, not just talk the talk, but also do the talk, right? Yeah.
Yeah, totally. Sinhu, how about Microsoft?
So I'll sum it up in 3 C's. Okay, so I'll give you 3 C's that you can easily remember. So one, and these are, again, like Cheryl said, these are skills or things that you would take across industries. So irrespective of whether it's tech, but tech can be applicable across industries as well. So it's relevant to all of these. So one is strong communication skills. That's something that any employer would look for. Make sure that you're able to communicate your ideas, you're able to influence for impact. You need to make sure that you're getting the message across, whether you're in the form of writing, whether in the form of speaking, you have to get your ideas across. The second is collaboration. You have to collaborate. So there's no one-man island. None of us can exist alone. So everything is a lot of teamwork. So you end up, whether it's creating code or building an application, or whether it's marketing, we end up doing a lot of teamwork. So collaborate is your second one. The third would be curiosity, which means be a lifelong learner, right? And continue to keep learning. I think there's no limit to us learning, and no matter what job it is or and sometimes you get disrupted. Now think about how COVID disrupted everybody, a lot of industries. And there were people who went right from being in the travel industry to learning DevOps and moving to a DevOps industry or role. So you have to be open to learning and being a lifelong learner. So no better place to start because we're at the Lifelong Learning Center. So those are the 3 C's. Thanks.
Yes, thank you. Yes, so talking about lifelong learning, Dr. Tifmang, so you have a lot of experience in education, and Kiwi also, Kiwi mentioned earlier, so whatever we learn in school, university might not be relevant anymore by the time we graduate. So what do you think? What should people do, like, to keep up with the rapid changes in technology to stay relevant for the job markets?
I think you have to recognize that the world is changing so fast that you cannot stop learning. So first thing first, get it right. Get into your genes, get your DNA, whatever you call it, lifelong learning. I think this is something that you cannot not afford to invest your time in. And of course, be curious. I think if you're curious, you're interested, you can find things out. And coming to a platform like the FOSSASIA, it's a good platform because there are a lot of new ideas. Just now, just sitting in, listening to the previous speaker. Then when you talk about why two systems cannot come together and then you create, if you change one thing, you've got to change everything. So these are the kind of things that stimulate you to think, yeah, how can I learn new things to adapt and apply? So lifelong learning, and always look for things that can be applied. And not necessarily solving problems, but sometimes it's just for your fun, your enjoyment. So don't just always work, but also enjoy. And then learning is a joyful process. So I would say always invest yourself and discover the joy of learning. I think these are important things for us to move on. And that's the reason why I always enjoy, I'm the CEO of the Science Center. That's the place that we play with learning. We encourage people to play and learn. And we are instead of learning, we are also instead of learners.
Yeah, thank you. How about Kiwi? Do you have anything to add on your own experience? So you you did not started as like a hardware maker, but now you making
I think
machines.
Dr. Lim has mentioned most of what it is like having the curiosity to learn. I think the only thing I can probably add, I will just come from the angle is that in this era of technology changes, but open source has been so established, right? Most of the disruptive technology all come from open source. So rather than seeing technology as a threat to your current job or expertise, you should embrace it and then use it. Since it's open source, right? Use it, enhance yourself, and then compete again. So that kind of self-improvement mindset, rather than a very protectionism. They say, oh, I want to protect my job because AI is going to take over my job. I think, why do you think that? Why don't you make use of AI to create like more product and more jobs for yourself?
Yeah, and so can you also like give some advice for the younger generation, how like to get started out in tech as a career?
I think that, I mean, this is just coming from an entrepreneur standpoint, is that if, let's say, you want to go on a hiring, I need someone that can be very adaptive, innovative, and willing to really look out for problem to solve, than someone who just waiting around taking instructions. I think we are right now in a new era when things are just been changing non-stop. Whether it's geopolitics, whether it's climate change, whether it's economic change, so on and so forth. I think the young generation will find themselves needed to adapt to changes and to deal with a very uncertain world. So those who can do that will survive.
Yes. So thank you very much. So we're talking about how the young generation can get into tech, but I also want to understand the people who are already in tech. So what helped them to get more advanced in their career? So what are the opportunities? And of course, I know that there are many developers here in the room. How can you create the joy in your work? Dr. Titmang said that, okay, if you find joy in education, find joy in the work that you do, you can advance much better, right? So the question is, what are the required skills in order to advance your career in tech? And what keep people motivated?
Sure. Well, speaking by experience, you just have to love what you do, right? Like, I came from sales. I was there for 8 years, right? And I got sick of having quota. Sorry for any salespeople here. I got sick of having quota. I was thinking, I want to try something else. You know, I want to change my lifestyle. I want to have, you know, I want to do something, try something else. Tried marketing, never looked back, right? So you have to love what you do. And I stuck in startups because I like the hands-on part. Some people cannot do that. That's fine too. Like it is what it is, right? As long as you're comfortable with what you do, you're happy. I think that's, and then the career will always follow you around, because when you're happy, you're productive and you keep on learning because you want to learn. But if you're not happy, then that's when you get stagnant, and that's when you sort of like lose productivity.
Yeah. So Cheryl, just a curious question. So you don't have quota in marketing, but what is the KPIs? For instance, if you come
What
here,
we do, we help the salespeople create a pipeline. So we call it marketing source pipe, right? So we do have a quota, but it's not as detrimental, I guess, if you don't meet your quota, your boss will kill you, right? But we do have it, obviously. Everyone has KPIs, right? So for marketing, it's marketing source pipe. We have to help the salespeople create the pipeline.
okay.
Yeah, and FOSSASIA, like events like this, obviously help to create adoption, and then ultimately some of these people will, but hopefully, buy our product at some point. Yeah.
Just a bit on the keyword there. She kept saying create. I think in a tech field, if you can create value for your company, for whatever agency you're working for, I think that is a very good indicator that you can progress more. And creating one thing I like to encourage people is that you should create with a community. You do not create all by yourself. because once you come together, 1 + 1 is greater than 2. And therefore, again, coming to advise the young people, you must be able to work with a team of people as much as possible because the combined strength is much more. I was just this morning at Meta, so I asked the people how they work. They actually form teams. And when they find that they need to solve a client's requirement, they bring in expertise to kind of make the team and so on and so forth. So I think this co-creation bit to create value is how you can progress.
Yeah, to add value. How about Sinhu? Do you have something to add here?
Yeah, I would say be a team player who demonstrates results. I know it sounds very, very corporate, but when you get down to what it really means, it simply means show results, right? You have to show the impact of whatever you're doing. The results have to speak for themselves, and that's what eventually then lets you grow because people see what you're capable of, and that's what then gives you more opportunities to take up.
Yes, I totally agree, and I don't think being a good team player only apply for corporates. I think in the open source community, we also need very good teamwork in order to success. Yeah, thank you very much. Kiwi, do you want to jump in?
No, it's okay.
Okay, good. So how are we with the time? So I think that it's time now to open up the floor to the audience. So let's see if we have any audience question from the audience. So everyone very successful now with their career. They all have very good job.
I can ask a question.
You are more than welcome.
I'm going to go a bit towards the hiring part of finding a job. We see these big companies, especially the big ones, Microsoft, Google, Amazon, maybe. They do this very focused data structures and algorithm for software engineers, right? They do these very focused data structures and algorithm interviews where you have to like type or write on a whiteboard and all that, right? And this has been very controversial in some tech communities. Like, are we assessing correctly students? Are we assessing correctly candidates? Or are we just kicking them out because they couldn't find how many windows are in New York, right? Given this, I think there's a very good option on looking at a candidate's profile if it's an open source contributor, because you can see what he does. But I want to know what's the panel view on this process. How can it be improved? And if candidates, because not everyone has the luxury to be able to work their daily life on open source. So what would be your, that's the second question, what would be your advice for the people that are not 100% in open source to somehow showcase their value through their work?
So I'd like to answer that and to the two questions. So the first is the primary thing that these companies are testing for is your problem-solving skills. So what they're trying to do, I mean, some tests, yes, may be more difficult, or the questions may be slightly harder, but they are constantly also revising all of that. But one main thing that they test for is problem solving. And how are you able to break down a problem where you may not have all the information? So sometimes, and this happens all the time in your day-to-day work, where we do not have all of the answers, we don't have all the resources, but you still have to go solve. So they're trying to see what would you do if you lived in all of these constraints, and how would you think and approach? So that's what they test for. And if they're able to see that you have a clear way of trying to approach a problem, that's what they want. The second, which is, if you haven't really done any open source projects, or if you're completely new to this, the one way that that people should go about this would also be to just self-learn. These days, it's a lot easier for you to do, let's say, to go after some online training, to consume content, to take up a certification. And I know that people who are not technical, and I'm not very technical, I can't claim I am, but it is easy to go take up certifications if you have the interest or inclination. So the first step would be, yes, go take some of those content or consume some of that, because then you're able to sort of get to a point where then you can meet some more like-minded people and try to get some foot in the door in terms of doing projects, etc. The other thing, and I think there was a person called Annie this morning who talked about something called the Code Without Barriers. This is a program which we initially started through Microsoft and with a lot of partnering companies to build women diversity in the tech industry and to upskill them. So the idea was we came up with, all of these companies came together to say, how do we upskill women and then give them a platform because they may not know where to start. So this program, the Code Without Barriers, we give them a way to upskill, which is consume some of that content, take up the certifications, and then to apply it, we give them the opportunities to participate in hackathons. So then they're able to use some of these skills to apply it for real life problems and solve it. So we invite them to be part of hackathons. And then we also give them mentoring. So I'm also, my evening job or my non-day job is also the mentoring and pillar lead for Code Without Barriers. So I look at pulling together mentors and mentees. So mentors who've been in the tech industries, and then mentees who probably are starting off or are career shifters as well, try to get them together and then to see how they can get more guidance in that direction. So getting a mentor again is a great way if you don't know where to start. And that's probably the journey towards landing an internship or eventually landing a job.
Thank you, Sinhu, for very insightful answer. Are you happy with the answer, Marco? Okay, thank you. Unfortunately, that is all the time we have for today. I would like to once again thank you very much, our panelists, for being here today. And thank you all for joining us. Enjoy the rest of your day at the FOSSASIA Summit. Thank you.
Next speaker is Fana Richie. Fana.
let's use this one, totally fine. Yep, totally fine.
When did you send it?
A few hours ago.
I don't know. We have time already. Can you use the stick?
Yes. Or even just,
Do you have a link?
yes.
CF Technical Advisory Group Observatory Chair, CNCF Technical Oversight Committee member, Governing Board member, and more. And he's been organizing, leading, and helping run a bunch of conferences. I can see here KubeCon, PromCon, FOSSDem, DENOC, DevCon, CCC, a bunch of cool ones. Yeah. All right. And he's going to talk about how Grafana Labs builds and sustain communities. The floor is yours, Richie.
Yeah, we're 10 minutes ahead of schedule, but I can also get started now. I'm completely okay. Let's get. Okay, let's do it. So, welcome everyone. Fun fact: the slides you're about to see are largely the same as we use in our internal onboarding and for our internal training on how to interact with communities. That's no mistake. We do believe in transparency and we do believe in sharing knowledge. So this is quite deliberately us externalizing things which we do, how we do them, and not only talking some random things and making nice noise about stuff. It's very much us externalizing what we do and live internally. So just out of interest, because I always do this when I'm in a little bit adjacent communities, who knows what Grafana is? Okay, that's maybe 30%, which is great because I always like having audiences where people don't really know it. So I probably don't have to ask you if you know what Grafana Labs is, but do you know what Prometheus is? Anyone? Okay. Kubernetes? Okay, no surprise. If you're using Kubernetes and you're not using Prometheus, you might want to reconsider. I mean, they're literally made for each other, and the two founding projects of CNCF. Anyway, so I'm going to start with a few theoretical bits, and then we go into the application part. So what is a community? A community is usually a group of people who have a certain commonality. This commonality might be in various shapes or forms. If you are into fishing or skateboarding or whatever, like you have some reason why you feel the need to meet with other people of that certain group. Like for example, open source. There are a few also in the source files. You can also click the things. You can download them. So if you want to read more on any of this, there's also source links. So there's a few when you come from German, and I am German. There is a few nice translations. Gemeinschaft and Gesellschaft. Gemeinschaft is this community, and you are based largely on roles and values and shared interactions, and a lot of this is intrinsically motivated. Like people can't force you to go to this one bicycling club. You come there and you go there and you keep coming there because you want to do this out of your own desire. Contrary to society, where a lot of interactions are not very direct, a lot of things like you send a letter or something is very indirect. You have a lot of impersonal roles and a lot of formalized values. and a lot is driven by external or extrinsic motivation. For example, you don't want to be fined. I mean, that's a good example while here in Singapore. Or you don't want other people to look down on you or something. So a lot of this is extrinsically motivated, not intrinsic. There's another translation of Gesellschaft, of where people come together, and that's cooperation. And this is very much based on formalized roles, and it always has an inherent structure. The others also have inherent structures, but not as raw, as easily seen as corporations. And part of why you are at a company, and if you're here for work, is literally called compensation. So you are being paid for using your time, for not being, I don't know, at the beach with your family or whatever, to do the thing you're doing at work. So this is very, very much an extrinsic motivation. And yes, any healthy company has a healthy internal culture. So what is community not? And again, this is what all the people joining Grafana Labs see, including marketing and including sales. We take this seriously. Communities are not a sales channel. They're not a marketing target group. They do tend to reject outside commercial interest quite strongly, as most people in this room would probably attest to. And communication with and within communities often has its own rules. It's not that you can just like go from one to the other and everything is the same. Over time, they develop certain patterns of communication, certain memes, certain in-jokes, certain ways of how to interact with each other. And it's important to take this into account and honor this kind of thing, because it's really, really easy to get this kind of thing wrong. So why do we care? And again, this is from the perspective of internal. A large, arguably the largest part of the success of Grafana Labs, and maybe I should explain this, because if you don't know what Grafana and Grafana Labs is, Grafana is a visualization tool which visualizes data for basically all databases you can think of. And people use this primarily for operations of IT, of cloud native microservices, whatever. But also you can use this at industry. I literally know someone who runs a port, and they have a weighting thing in the conveyor belt, and when they take on coal, they can see how heavy the coal is. From this, they deduce how much moisture is in the coal, and they can stop the conveyor belt when it's too moist, because it would spoil the rest of the batch. So that's all of the things that you can do with this, and Grafana Labs is the company which provides this open source, but also sells services based on this. So, and this, again, is something we teach the people internally, and also which is coming directly from the founders. That Grafana Labs honestly tries to teach the community well. And the communities, as you can see, are also repaying with engagement, are also repaying with like attending conferences or speaking positively about a thing. So there is also quite some egoistic motives in this from the company perspective. But the good thing is we found a way to align those incentives, so we don't do open core or anything. It's true actual open source. So the thing is that as a company which actually is built on open source, we actually do believe that this is a strategic requirement for the continued growth of the company. And if done right, and this is also part of being honest for anyone who invests in community, like I'm director of community, Grafana Labs pays me to do this. Yes, there's something we get back, and that is that this is an integral part of the sales motion if done right. Another really nice survey, they did one again, I think, last year, but the results are basically the same. Stack Overflow asks how developers choose software. And if you look at the first three, starting a free trial, asking other developers, and visiting developer communities, those are things which are done really well within open source. Open source enables all of the three of those. Of course, you can just use it yourself. You can try it. You can talk to others who are using it. You can find people at conferences who are excited about it. So leveraging this dynamic where software is eating the world, and as such, developers are eating the corporations or defining the corporations, and more power is given to developers. You can actually shape as a company what people, way before they ever have a potential commercial conversation with you, use or do not use by honestly making the open source absolutely stellar and supporting the open source user as if they were paying users. There's also a personal example in this. I've been in open source for 25 years by now, which is a long time. And there was something within Prometheus. Again, Prometheus is a monitoring tool. It's a database for metrics, and it is tightly coupled to Kubernetes. So the type of monitoring or observability data which Kubernetes emits is precisely in the format which Prometheus ingests precisely course Prometheus exists. So they are super, super tightly coupled. Anyone who's using Kubernetes in any way or form is using some way of Prometheus or Prometheus compatible software. And in late 2015, early 2016, it was me as a member of the Prometheus team, not working at Grafana or anything, recommending within Prometheus, hey, can we deprecate our own visualization solution? Because Grafana is so much better. Is this something we would be willing to do? And yes, we were willing to do. And this has had an outsized impact on the trajectory and on the growth of Grafana Labs, the company. That was years and years before I ever, me personally, ever even thought about joining Grafana Labs, or I didn't think I would ever do this. And still, from a purely community perspective, I just trusted the people who did this. So what makes a healthy community? Well, again, every community forms around a common cause. For example, ethics and such in open source, where we believe in carrying stuff forward. And they tend to coexist and work together. And the causes tend to remain long-term. So if you have someone who's KDE and you have someone who is Genome or VI and Emacs or whatever, or Gen2 and Debian, yes, they might interact, and you might have people who are part of more than one community, but those communities tend to really carry whatever their cause is forward long term. They tend to not merge. Like even with VI and NeoVim, you see that there's different groups who the one really use VI or VIM, and the others really use NeoVim, and there's not huge overlap. Like some people migrate, but the actual communities, the mailing lists and everything are relatively static. And you have to just accept this, and to both as a company or as a community manager or as someone who works with the communities, honor this kind of thing and not just enter something and just try and shove everyone to a different direction. So on respect and on trust, humans are herd animals. We are optimized for social interaction. Being an introvert myself, some of us are optimized for social interaction to varying degrees, but as a species, one of the reasons why we have survived and thrived is, of course, we have social interaction, and as such, we can do more than the individual can do. And this means that a lot of the things which you do while interacting with other humans or with any other system made of humans, a lot of this is built deep into your psyche, coming from your DNA, coming from thousands and thousands and thousands of years of basically people dying or not dying because they starved, because they didn't work or work together with their group. So a lot of this is automatic in the background. So if you don't feel respected in a certain group, you will not want to interact. And if you can't trust that you are safe within your environment, you will either just leave, or you have significant overhead in your interactions with this community because you just don't feel safe. Which means you might retract from that community or just like not be as open because you are always thinking about protecting yourself and not about actually engaging within the community. On the flip side, if you are accepted as you are, and if everything is positive, then yes, social interactions will actually feel positive and energize you. If you're not, they will feel draining. So yes, we need to safeguard communities. That's why we have code of conducts. That's why we have diversity drives. That's why FOSSASIA and FOSSDEM and others are working so much on those kind of things. And there's a few caveats. We're really, as a species, hardwired for fight or flight. And it is fully automatic in the background. You can influence this to some extent, but you cannot fully do it away. So automatically, when you're exposed to negatives, all of this starts running in your head. So if you don't feel secure, you will act more insecurely, you will act more defensively, you will also act more aggressively, and others also fall into this pattern. So if you come to this inflection point of a vicious cycle where things just devolve, it's really, really easy to basically lose whole communities and just have them go down the drain. Of course, a few people were initially maybe not very nice, which is with my, for example, my FOSSDEM hat on, or many, many moons ago with my Freenode hat on or so, we were extremely quick and vigilant about stopping things early, because once they devolve to a certain point, it's almost impossible to get things back. How do I do it? Okay, I'm going to. Yeah, and also iron law of institutions. Anyone who's in a position of power within any organization is much more likely to defend their position and see this organization wither and die than to just give up whatever position of power they have and be like, okay, it's someone else's time. By extension, communities tend to fade away over time. I mentioned a few Linux distributions, some of them maybe. But they are very, very unlikely to actually change. So it's much more often the case that communities simply go away and fade than that they really change trajectory or change what they're about. And speaking from a company level, this is really important to take into account, because if you have, I don't know, a big migration or something, doing this in a consistent and respectful manner, which actually pulls people with you, is exceedingly important to your success. So yeah, safeguarding. As we are social animals, we are really good at detecting situations which just don't feel right, and all of us will have had those situations where we just don't feel safe, just don't feel it's weird. Children are really good at externalizing this. Then we are taught to not externalize as much, because that leads to less fighting, but it also leads to people being less honest. But the thing is, communities really depend on open and honest and transparent communication. Like, for example, literally putting internal slides out into the open as something of, hey, this is how we think about it. And you can really only safeguard communities from within. Like, it's literally impossible to just swoop from the outside and be like, okay, I'm going to fix whatever. No, you won't. Unless you have respected members within the community, you have good standing and some position of power or influence or whatever, you can't put them in a code of conduct enforcement or safeguarding situation, because they will just be rejected. Like, if it's really bad, yes, get police and everything, but then we're not in community, then we are in society. Or get your boss's boss, then we are in corporation. But within community, you can only do it from within. For anyone who interacts within communities, and this will be hopefully 100% of the attendees here, I highly recommend creating culture canaries for yourself. There you find certain things about a culture or about social interactions which you like, which you do not like, and you deliberately think about them, and you deliberately write them down, and every X amount of time, 6 months, 2 years, whatever, you actually go through them and check yourself, am I still honest with myself? Is this still the same community? Did certain things go in a direction I don't want to? Can I change it? Should I pull back? Can I ignore it because my own outlook on things changed? But having this and doing this on a somewhat regular basis is really, really, really powerful. And the best examples are usually the ones where things go wrong. Like someone does something bad, says something bad, whatever. How is enforcement being handled? Is this a super painful process for everyone, or is it as okay as it can be made? And in the end, there's a public and transparent summary, and everyone moves on and is able to move on, except for people who might be kicked out or whatever. Things like these tell you much more about how people, how communities actually behave and interact than just randomized words on a mission statement. The summaries, basically to avoid changing your own definition of what you accept within a community interaction, write it down, keep yourself honest about it, and never ever talk about it. If I tell you what my culture canaries are about, for example, interactions within giving talks, they become more or less useless. Of course, people can start optimizing for them if they want to push me in a certain direction or whatever. So yes, you can make suggestions to others if they don't come up with their own, but don't just tell them your own. Because as Goodhart said, when a measure becomes a target, it ceases to be a good measure. So, formalizing all of this. Most communities have at least informal roles. This person who always shows up and does a certain thing over years and years. We have this at FOSSDEM. I'm certain we have this at FOSSASIA, where people don't even like have real formalized roles. They just show up and they do the thing and then they go away and they just keep doing it. There's also obviously formalized roles, in particular as you grow, as you, for example, need a legal entity, and once you need to start handling money and such, you need to have some structure and you need to have people within that structure who have formalized role, because that's how you interact outside of the communities, but they always have informal ones. Visible and transparent structures. So how can I actually interact with this? Like, if I have a complaint or if I want to help with, I don't know, shepherding speakers or whatever, how can I interact with this? How can I get started? Which by extension means writing good documentation about the communities you care about the communities you run, to enable people to actually come and start helping out if they so choose. Some structures are a signal as much as a tool. Prime example is code of conduct, because the best code of conduct is well written and everything, yes, but the best code of conduct would be, in theory, the one which would never ever need to be enforced, because everyone already acts in a positive way. And that's not a function of the code of conduct being written well, that would be a function of that community being perfect to some extent. So this is both. It is a signal that yes, by having a code of conduct, you signal that yes, you do take things seriously and that you actually formalize and write down and expose and externalize how you think about things, how you will treat things if certain things happen, what you find acceptable, what you don't find acceptable, what you list, what you don't list in those lists, but also as the tool for actual enforcement, and obviously then as the run through, and as the person who always gets pulled in when we have anything code of conduct within Grafana Labs, which is thankfully very, very, very little. The point about enforcement is quick, early, transparent. If you just pull it in, oh, we're going to form a committee and we're going to talk about 10 years for like that thing, and maybe you'll get a reply, and maybe you won't get a reply, that doesn't build trust. It's not a soap opera, so you don't have to do all the details in public. You absolutely shouldn't, but at least at the end you should post a summary or a once yearly report or whatever, where you just say, okay, this is what we did in the end. So there's also limits. Communities exist within a context, within the society. If here, I don't know, the fire protection brigade comes and tells us we are not allowed to have this, of course, random example, I don't know, we can't just continue having this talk. We have to actually follow whatever the rules of the society are we are within. Your fishing community can't overthrow the government, I hope. And also, if someone who's external to the community or in the community decides to just unilaterally change a thing which the leadership of the community or of that project decided differently, it won't work. So there are still limits to this. So yes, they have limits in the impact, and it's really important to be aware of them. Applying all of this. So most, and again, this is the internal slides on purpose, no changes. So the hour here is Grafana Labs. At least for how Grafana Labs chose to interact with open source is that the products are actually based on open source projects. And the vast majority of what you have in open source is what makes up the product. It's maybe 98% of the code base. We have a very thin veneer of differentiation on top of the projects on purpose, because we want to have healthy long-term projects and healthy long-term communities. And the thing is, the communities themselves usually don't really care about the products. They mainly care about the projects, and that's fine. And that's something where, as a company, you have to be really, really careful to not overstep the boundaries. Again, open core is a good example where you basically put all the really important bits and the really useful bits behind a pay gate, and people stop using your product as much and your project as much. We've seen this with several competitors to Prometheus, to Mimir and others, which tried this and failed, and that's part of why Grafana grew so much. It's important to have an open governance. Speaking with my Grafana Labs hat on, we have a lot of projects which are under the umbrella, under the legal umbrella of Grafana Labs, but the governance is not completely tied to Grafana Labs. So you can join the project, you can have votes about stuff without Grafana Labs deciding every single thing. In my specific case, all of the governances within the Grafana Labs projects are based on the Prometheus governance. Of course, I'm part of Prometheus and I liked it. All the communication happens on GitHub, on mailing lists. Like, obviously you have some work stuff and such internally on Slack or whatever, but the vast majority is on issues in tickets and things like these. It's important to have the membership truly open to everyone, even competitors. We have people working like with formalized roles as full maintainers with full voting rights on Grafana Labs projects who are not employed by Grafana Labs and never plan to be. And no matter if you sponsor as a company someone else being a member of some project, or if it's people who join your projects, membership is always personal. It's not the case that, oh, they pay X amount of money, or we have this and that partnership, and now we make this and that person this and that role. No, it's a person who does the work. They might be sponsored by their company, or they might not, whatever. But the point is, them as a person are the one who actually are part of the project, and also are, if they move companies, they still retain the membership. They're not kicked out. There are other projects who do it differently, and I strongly, strongly disagree, and I strongly implore you to never ever do this, because it kills the community over a relatively short amount of time. So what does it mean to be project first? Every project which you nurture should have a community lead. That doesn't need to be a full-time role. Ideally, it's not a full-time role. Ideally, it's someone who's driving the tech or the people or whatever within the project forward anyway. And it's important to identify the people who like doing this work, as opposed to just assigning someone and then they don't find a lot of fun and positive sentiment in this, and that they basically don't do it. There are a few mechanisms which we like to apply. For example, community calls. For us, this means a monthly call, always the same day of the week, always the same time. Yes, time zones, and yes, UTC. Still jet lagged. Summer, winter time, things like these, but still, like, keep the same time slot. Make sure everyone can join. Don't gate on like subscription or you need to register or anything. Just let people join. Make certain that everyone can actually bring topics. So it's not just you talking to people, it's an actual exchange of ideas, actually talking with each other. Make certain that everyone can edit those notes. It's not the case of you writing and defining what the reality of that meeting was. No, everyone should be able to put stuff onto the agenda or to help write your notes and make the recordings public. Other things which we like to apply is we have a meetup series called Grafana and Friends, which is in various cities around the world. It's always in cities where we have 1, 2, 3 dedicated people who actually are committed to running this thing long term, and then we help them with like finding venues or getting pizza money or getting speakers, maybe paying for a speaker to travel to a place to speak at the meetup. Things like these keep local communities healthy, and that's why we as Grafana Labs do this, to keep our communities healthy. Public speaking, yes, like Grafana Labs is paying for me to stay to be here, and not to talk about this and that product which you must buy. I'm literally giving you the internal presentation from the onboarding. Grafana Labs does this because we do believe in open and transparent communication, and just by externalizing what we do, that we find other like-minded people who either like this thing and want to use the stuff, or maybe want to work for us, or maybe want to support it and buy from us. Like, all of those are fine, and all of those are intended, obviously, but we are not forcing anyone. We are actually like paying for people to speak about completely irrelevant stuff at conferences, big and small. Blog posts at Grafana Labs are written mainly by engineers. Well, not mainly anymore, but at least for the tech topics, they are written by the engineers. We have a lot of non-tech topics these days, or non-Grafana tech topics, which is sometimes hard because upper management is like, okay, there's an engineer. That engineer is really expensive. Why should they be spending half a day or so to write a blog post? I can have them implement a feature in this time. So this is an actual investment into making certain that, yes, the people who built the thing are also having a public voice and speak to the wider community and show that, yes, there are humans where they had issues, how they went through. And obviously a ton of webinars where you just explain your stuff and do this again and again and again and again. Because one of the truisms of the fundamentals of tech, like for example this talk, is the actual content doesn't change, the audience changes. Like your math teacher at school, they will probably start their career and end their career teaching the same math. And that's fine. It's not that the content really changes, it's that the audience changes. So yes, webinars and just repeating what you've been saying forever is also good. As I said, engineers are expensive. Travel is expensive. And if you only send marketing people, or if you only send field engineers, at some point you will lose authenticity within the wider communities. You have to actually send the people who do those things. So one of the reasons why Grafana projects are so successful, and one of the reasons why Grafana as a company is so successful, is because we actively invest engineering time into public speaking, writing blog posts, interacting with the community, and basically just doing good stuff. And people take notice and they appreciate it. Yep. Final words of warning. Again, this is internal, and every sales and marketing person being onboarded sees those things. Keep marketing and sales mechanisms away from community mechanisms. You will mess up interacting with your community. You will also mess up in other ways and forms in life, in your work, in wherever, because that's part of being human. When you mess up, be honest about it. Be transparent about it, learn from it, document it, whatever it was, and move on. And everyone else does the same. And again, this builds towards this psychological safety. We are social animals. You don't want to put someone into this fight or flight, or just think that you lie to them. Because if you're dishonest or treat communities just like a random sales or marketing initiative, they will absolutely turn away. That community will die, and your project will also wither. Thank you. I think we have time for some questions.
I was just curious, where can we see which cities have Grafana and Friends meetups?
Meetup.com.
Okay.
Just go to meetup.com and search for Grafana and Friends.
With the code of conduct, some conferences do transparency reports. They anonymize it, but everyone knows. It can lead to like defamation cases. What's your thought on transparency reports for code of conduct?
I think they're good. I also disagree that everyone knows what they're about. Like depending on the size of the community. If you have a group of 50 people, yes, everyone will know everything, and of course. But like for example, just yesterday or today, Linux Foundation put out a report, a transparency report on code of conduct and enforcement, and I knew about one single of the cases out of maybe half a dozen or so, or maybe a dozen. I strongly believe we need to have them, because the thing is, again, any investigation into a code of conduct issue is not a public soap opera. Part of protecting the victim or potential victim, or at that time alleged victim, and everyone else is to not make everything public and to actually take everything private, have actual deep conversations, talk to the people, have interviews, blah, 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 blah. So by definition, you pull everything very, very private. The one way to validate this kind of thing is only by being transparent after, to the extent that you can, that you actually prove that you did something. So you can talk about, okay, as a result of this complaint, one person was told to to not interact with this community anymore, or they will not be invited to the events anymore, or they need to have a cool down period of X amount of time. Linux Foundation also had someone apparently go to counseling and provide proof that they did go to counseling, like whatever. But you have a paper trail of, yes, we did engage with this, and yes, this is the rough thing which happened, and this is the rough outcome. So people who are thinking of, should I be considering to join this community, actually see proof positive that this is what you're doing. Anyone else?
Anyone else? More questions?
If that's a question, I feel honored.
Richard, I'm just curious, your title is Director of Community. What do you do exactly? Do you write any code?
I don't write any code.
So what do you do? Your daily
It's a
work?
very good question. The answer changes more or less daily, and I'm not joking. So at a very basic level, I care about the continued strategic success of the projects we care about, which is primarily all the projects which we have ourselves, plus in particular Prometheus and OpenTelemetry, because they're highly relevant to us as a company. Which means, for example, organizing the dev summits for Prometheus. Until last year, running PromCon, this is the first year I'm not running it, yes. Things like these, writing the governance, making certain that the code of conduct is applied everywhere. All of this, but way, way more. Like giving public talks, helping internal people give public talks, polish their CFP submittals, a lot of license work. It's endless.
All right, one more question. Anyone? I have one. A bit going on with the maybe with the people, like the structures of communities, like the governance and how they work. Do you see like different communities have different governance methods? Do you see certain methods being more effective than others, and would you advocate for some of them?
It's a very, very, very deep question. So I know of at least one legal umbrella which had to actually break their own bylaws because they were in such a stalemate because people didn't vote anymore. Like they had too many members who became inactive, and with a little bit of wink wink, nudge nudge, and a lot of closed eyes, they basically did one move to get back into an operating state again. As a member of that thing, I fully agree of like, yes, this was the right move. So one of the things is be careful that you stay operational with your community, with your governance, which means you need to prune people who become inactive every X amount of time, either by asking them nicely or by kicking them out, or maybe they realize it themselves, but most people don't leave, they just stick around and stay. So that's one of the things. The other thing is try and prevent hostile takeover, because there are so many examples where a company is paying directly or indirectly and then just have enough people in positions of power and then they flip the switch and they own the thing. That's also not great. As a general rule, I would say if you're still small, full democracy is good. Don't require a vote for everything. Put in consensus mechanisms where, like, for example, similar to IETF, you have a rough consensus, and once rough consensus is achieved, you just move on. You don't have to wait for every last person to voice their opinion. You just move on, and everyone can progress and keep pushing the project forward. For important things like changing governance, adding people, have votes, have formalized votes with a very rigid structure and time boundaries of you can only run it for X amount of time, for example, 2 weeks. Have different limits of acceptance rate, like it's a different thing to add a person to a project than to kick one out or to change the governance, like have different levels for this. And once you are above a certain size, it usually is most efficient just of how human and communication works, because n squared growth rate, blah, blah, blah. To have a inner core of sort of trusted people like governance committee or steering committee or something. Usually it should be an uneven number. 3, 5, 7 is good.
Hello. Yeah, thank you very much. I think we're going now to the coffee break. So everyone, there's coffee probably downstairs. We'll see you back in 45 minutes. Thank you very much, Richard. Very inspiring.
Thank you.
3:45.
Talents inside the company. So let us go ahead to the today's agenda. I have 10 minutes, so I have named 3 things: data, AI, and you. Many talk. In fact, FOSSASIA, many topics about AI, this big AI, data, and open source. And nowadays news, there are so many about news, ChatGPT and that stuff. Every time there's a news that came out, my boss will call me in the room. William, they have this, we must teach our students. I say, no, wait. Don't get confused, okay? And maybe I'll offer you 3 steps to how to grow your AI and talent pool, and after that, question and answers. Data, AI, and you. So what is your response to data, big data, AI, and you? Let's have a show of hand. Is this the first emotion you encounter? I do not know anything. I know nuts about it. I'm confused. I'm worried. I am perplexed because everybody say ChatGPT is so good and that AI is that good. I know nuts. Or this is the next thing. Frustrated. It seems so difficult that I can't achieve it, can't do anything about it. Well, I hope this should be your last response. You're happy. You're able to use technology. You're able to use data. You're able to use AI to grow your company, to ride the wave of digitization. So this is something I hope you, maybe if you are in the middle or frustrated, hopefully after my PowerPoint slide will give you some hope of light for the future. Okay, so this may be the current emotions we feel about big data and AI. So confusing, just like a Scrabble, right? Full of noise, full of things. Everybody is talking about it. But do you know the solution to AI is not about technology, it's about you. It's not how good is the technology, how smart is the technology. It's about you. You want to use AI or big data to solve your problem, you are the solution because you know the business. If you do not know your business, please do not use data, use AI. You must understand your business, then you're able to use data to visualize, to predict, and come out a solution. And many people miss out this. Everybody blow out proportion about technology. Wow, this is so good. Wow, so this is good. Look, hype is for stock market. And this is what I tell about my students. Hype is for stock market, it's not for you. You need to know and understand the problem. Then you're able to solve it. Next thing about it is about AI and big data. You are human. I already told students, I teach my students this thing. You want to use big data, you want to use AI effectively, you must be a human first. You understand human nature, you understand human behavior, then you are able to use data and AI correctly and properly. In fact, nowadays I look at all the big AI technology out there. Those are in the news. Personal thought is going to destroy their own product that they have been built up all these years. Why? They forgot about trust. They forgot of how to become a human. So there is full of thought. So be not perplexed, be not worried. To use big data and AI effectively, you are the solution because you know the business and you are human. That's why I'm here. Therefore, I offer 3 steps that offer you to help you grow the AI and data and talent pool with us. First step, step number 1, 2, and 3. 1, proof of concept. Proof of concept, start small. Second, internship. Engage students, whether be with us in ITE, the poly, or the university. Engage us. Get them because they are the future. Next, grow talent pool with us. So 3 steps. 1, proof of concept. Internship. Next is talent growth. So let's look at proof of concept. Proof of concept project. Start with proof of concept. So it's 1 small step. And that's the, right, you can follow up the next quotation, right? It's a big leap for human race in the moon. Just take 1 small step to AI, to use AI and data. Don't think too complicated. And that is actually what happened during COVID. One company come in and talk to us. Say, William, we want to try AI in my business. We are traditional business. We are people that sells, well, let me show you the next video. This. We are engaging construction, chemical people wearing helmet vest, personal protective gear. I want to transform my traditional business into this area. Can we use AI? Can we use data? So they say, okay, let's try. Why not let my student try it? And get them, must I pay my students? The answer is no, it's free of cost, free of charge. Because it is an industry project to get our students practice what they have learned. So during COVID, I have one group of students that are challenging to use AI to test whether construction worker or factory worker, whether they are wearing their personal protective gear correctly or equipment correctly. So this is their proof of concept video. I gave the student a few months. They research. They use their TensorFlow, Python code, their experience, and they get all hold of Intel OpenVINO, which is an open source library, right? And you can use it and test it out. So you see first one, without wearing gear, so it's red. Now, those who are wearing full gear, it's green, right? And that's my student doing testing. Again, proof of concept, nothing fancy, right? And now he's taking out. Where it turned green? Yep, it turned green, turned red, sorry. Right? Look, and we show it to the traditional company who is doing this kind of sales. Right? The personal protective gear sales. After this, the company say, oh, all right, if ITE students can do it, I believe we can get this project up and do it in a big scale. Of course, they did not continue us to do a full-blown project. They continue to engage an external party to do it. But it is one small step for the company to move further than that. So, step one, why not engage us? Give up your problem statement. The problem statement is small enough to give proof of concept and let our students start tinkering about. It's a simple 1 month, 2 months, 3 months project. Let them tinker about it and let them show you the results. Next. So therefore, we have 2 courses that actually look at data and also AI. One is higher NITEC, which is what is NITEC? NITEC is National IT Certificate in Data Engineering. And next is higher NITEC in AI applications. So what is these 2 courses? And you can engage them to do the proof of concept project. So for higher NITEC in data engineering, basically, you need big data. You need to clean it up. You need to put it inside a database or a data lake or data warehouse. You need to process it, clean it, visualize it, right? And that is the skill sets that the students do. Support collection of data process such as data labeling, data categorization, data digitization, conversion, organizing raw data, and so forth. And most of you who are here when the AI and data field, you'll be familiar with all this. So it's to get them to visualize, to make sense, take insights of what you have. And let's say you have a lot of data, you don't have anybody to go and label it, engage our students to do it as a proof of concept. Right? So that is high NITEC data engineering. And of course, the next course, this is my sister course, and this is a course that I'm handling, AI application, where we are training students to become associate AI engineer. Right? First, we start with mindset change, where we teach about AI ethics and also software development practices, where you come agile development coming. So we have to teach them to be human first, okay, and how to do software development in the correct way. After changing our mindset, then we look at coding skill, where we teach 2 things. Python, programming essentially is basically Python. Mobile application programming, which is Android. Why you ask me Android? Because we are seeing some of the application moving down to handphone, mobile phone, all the way even to microcontroller, right? Where you talk about tiny machine learning. And our students have to go through very tough training because they have 3 practical exams where they have to code 1.5 hours, code from the top to the bottom, right? First exam, practical exam, computer vision essential, 1.5 hours talking about computer vision. And the application will be, we're doing drones and another open source project, which is Intel OpenBoard, a fun project, all right? 1 minute, so I have to quickly wrap it up. Natural language processing, also practical exam. After that, data, where we talk about data all the way to AIoT, which is the current course they are doing now. Okay, after this, the third internship. And we have 6 to 9 months internship for these 2 courses, where you can engage our students as interns and work with us. And I given all my students 1 project, 1 target in this FOSSASIA. Please find an IA company that want to engage you for internship in FOSSASIA. So please engage them and talk to them. And the last one, which is, and you may do a full-blown project with them. And this is another example from our group where they did a project during COVID. Let me fast it up since of time counting. Is to do what? Whether you wear a mask or not wear a mask, you're doing social distancing. There is a very full-blown project where they can send the data to a Telegram chat and tell the enforcement officers that somebody is flouting the rule. Okay, and this is featured by China's News Asia. And that's one of our students. And this project, of course, is longer term. It's 6 months. They really spend a lot of time to do it. And they channel the information to a Telegram app to tell the enforcement officers that somebody is flouting the rule. And you can engage them to do that during their internship. Third step, a work-study diploma, which ITE is now doing, where you employ the trainee to be your employee, and after that, give them time, maybe work 3 months in your company, 1 month back into ITE to go do intense training. What kind of training they will cover? So let me quickly run over. And what does this work-study diploma entails? Very importantly, it's heavily funded by SkillsFuture. So you get benefits, students get the benefits, trainees get benefits from SkillsFuture, companies get the benefits from SkillsFuture too. And you get ready trained worker in the area of data and AI. All right, so there's a quick summary. So what are the certifications? So these 2.5-year program, they work and study with you. It's quite similar to the German model, right? Where we have the foundation, where the students will learn about programming, all the way to exploring data analysis, data preparation, project management. Second year, we speak to 2 tracks. Let me quickly run through. AI and data track, so there's a group of students go on the AI track and the data track, where they go deeper, because at the end of the 3rd year, they are supposed to do a capstone project in the company and showcase it. So within these 2.5 years, you also encourage students to get also the industry certification from Google, AWS, from IBM, from Apache, and so forth. So that is what we are actually getting our students to do so. And Keystone is, we are launching this in 2024. So we encourage companies who are interested to grow, to have your talent pool grow, to join us in this program too. Okay, with this, I come to my last of my slide, Q&A. Feel free to connect with us. This is my QR code. You can link, connect me, we link it. And my email is very simple, william_tan@ite.edu.sg. If you have any question. If you can't even get my contact, don't worry, my students is up now in the FOSSASIA for these 2.5, 3 days. Get hold of them and refer them to me. So we maybe have a quick question. Is there anybody have any questions?
All right. I think we don't have much time, so we're gonna keep going on. Thank you very much. Thank you very much, William Tan. So let's give him a round of applause. And yeah, if you guys want to connect with them, you can scan the QR code. We also have these QR codes on the badge. So if you want to exchange contacts, that's another easy way to do it. Next up, we have Frank. All right, so our next speaker is Frank Karliszek. Is it Karliszek?
Correct.
Thank you. He's the CEO and
Help to specify the activity hub API standard. I'm a fellow of Open for You with the open source strategy, but I think I'm probably most well known and invited here to be founder of Nextcloud. But today I want to not specifically talk about Nextcloud, only a little bit at the end, but more about AI and the challenging around it. I mean, we all saw the hype and the explosion that happened around ChatGPT and generative AI in the last few months. It is obviously a huge topic. I personally believe that the job of computers and software is to make our life easier, to remove boring tasks from us, to remove mental load, and just to make our life, our society better. And this is, of course, the goal of AI, and there's a lot of potential behind it. Unfortunately, we also saw the last few months like the dark side of AI, where we see the problems that it might cause. It might problems around privacy. It might be around CO2 emissions, climate change. It takes a lot of power. There are some challenges around discrimination and some other things, which actually brought we from Nextcloud into a challenging situation. Because on one hand, we want to provide to our users the latest technologies, the latest tools, and there are a lot of opportunities to do cool stuff with AI. On the other hand, we have our own ethics and our own values, from open source to protecting privacy and so on and so on. This actually led us to, after a lot of discussions, to start an initiative around ethical AI. And this is something that we want to basically use to judge and to categorize the different functionalities based on what we think is like ethical, what is like not so good, and what is really, really bad. This helps us to reflect on our features that we implement ourselves and also the AI features that we integrate into Nextcloud. Okay, let's talk a little bit more about the problems first that are there, and then later for a possible framework to address that. The first problem, as I already said, is of course the CO2 footprint. I mean, if you look at this statistic here, you can see the energy consumption of different things. On the left side is just a flight in a plane. Then we have overall the human life, what we as humans basically cause on energy consumption and CO2 output. Then there are other things like cars. And then at the right side, you see the training of a mid-size AI model. Right? The reason for that is obvious. It takes a huge amount of GPUs, huge amount of power. So the CO2 footprint is really significant. This is a bit of a problem of the whole AI thing. The second thing is around discrimination. I mean, AI systems can be used in lots of not ethical ways. Examples are, as you can see here, systems where, for example, the police here in the US is judging who might be a criminal and who might not be a criminal based on certain things, like in this case here, for example, color of the skin. So how is that? The reason is very obvious, because AI systems are trained based on like data on the internet, right? Public available data on the internet. And as we know, in our society, we have a lot of discrimination, racism, and other problems. And this directly is fed into the AI models, which amplifies that. And this is, of course, a huge problem. Next challenge of AI is the whole area around privacy and security. There was a story last week that Samsung employees basically used ChatGPT, sent their data to ChatGPT to have it analyzed and it's obviously a data breach because then the data is left the company, it's no longer protected. I really laughed when I saw the story because this is not new. I mean, this happens all the time. This happens with translation systems. Who of you sent like internal documents already to DeepL or Google Translate or other services? I mean, this is something that happens all the time, and this is of course a huge problem. The next challenge of AI is just the concentration of power. And we all know that the really big machine learning models, GPT-4 and so on, this is something that at the moment only big organizations can do. So basically heading into a future where only like 5 big companies can really do all these advanced machine learning things. And this is of course a problem. Last one is the availability. So there's a study lately from Oxford done where it basically researches who has access to AI technologies and who doesn't. And this is the map, this is the result of this study. And as you can see, in the rich areas, it's obviously easy to do AI stuff, and in not so rich areas in the world, it's really hard. So the digital divide is getting bigger and bigger. So these are challenges. Again, what can we do? We can of course say, okay, AI is bad, let's not use it, but it's not really the solution because there are also lots of good things that can be done with AI. And again, we want to do ethical AI at Nextcloud. So after lots of discussions with experts and also internals, we came up with like 3 requirements where we want to measure different AI systems on. So the first requirement for an ethical AI system is that the code is open source. And with code, I mean the code that's used to train the model and also the code that's used to use the model. Okay. So why is this important? Because only if the code is open source, you can run it yourself. You can actually look inside. You can optimize the power consumption. You can even measure the power consumption, right? With lots of the hosted AI systems and OpenAI, for example, no one really knows even what the power consumption is. No one really knows what's happening behind the doors. So open source is a key. Second requirement is that the model should be freely available. Why is this important? Because if it's freely available, you can run it yourself. You can run it on premise. You don't have to send your data to some web service that you don't not really know what's going on. Second reason, if it's freely available, it also means that everybody can use it, right? Even if you're not a big company, even if you're just a student, there are tons of students here, it means that we can all play with it, all use it. So this would be a requirement. Third requirement is that the training data should be freely available. Why is this important? Again, because if the training data is available, you can actually check if there's discriminating data inside, and you can improve it, you can remove it, and improve it. If the training data is not available, then it's a complete black box what's happening, and that's not really good. So based on those 3 criteria, we developed this ethical AI scoring system, where we say code availability, model availability, and trained data availability, it gives points. If you have all 3 points, then we consider this a green ethical AI solution. If you have only 1 or 2, then it's yellow or orange, and if none of it is available, then it's red. And we already use the system, I will show you in a second, to judge our own features we have, also integrations we do, and also the roadmap for the future where we invest energy into and where not. Okay, let's go a little bit through into, and now it's Nextcloud specific, but I think you can translate this also to other software. Let's go through the features we already have and see how we are doing here. You will see at the beginning, it will be really a lot of green. At the end, it will be a lot of red. Let's just start with the easy things. So here, if you know Nextcloud, then you know that on the top, we have a system where we recommend files to you. So recommend files to you based on behavior in the past. We do some intelligence features here. And this is a system which is, according to us, ethical because the data is available, the training data is local, no data is leaking anywhere, there's no discrimination. Next feature we have in Nextcloud is a system where we train the login behavior. So you train who logs in from which IP address at what time. So we can basically detect if someone logs in from a different continent in the middle of the night, then it's maybe something that is a bit weird. And again, this is a system like machine learning that happens on the server, no data is leaking anywhere, code available, and so on. Another feature we have is face recognition. So if you use Nextcloud Photos to upload your photos, then we can actually recognize faces and group them by people. That's a feature we implemented last year. This is a system where the model is running on your server. It's trained by 3 million publicly available faces that can be verified to have no discrimination. And again, this is a system where the data is available, the code is available, the training data also. So this is a green ethical IT system. Similar to object recognition, again, we can automatically detect certain objects if they're uploaded in the photos to Nextcloud. Again, this is a model that runs local and everything is open source and there's no discrimination. It can be verified that there's no discrimination, so that's an ethical system. Now it gets a little bit more interesting. Another feature we can do is actually music recognition. We can actually detect the genre of different music. So if you upload your music collection to Nextcloud, we can automatically detect if a certain song is like rock or Latin or metal or whatever. And this is again using a machine learning model that runs local. So your music is not sent somewhere else. But unfortunately, that's only yellow. So why is that? Because the training data comes from Spotify. So on Spotify, obviously, the music there is not publicly available. But at least the model is available and the code is open source inside Nextcloud. Next feature I want to mention is that we have these related resources. So based on a document you're viewing at the moment, a folder you're in, we automatically show related chat channels, calendar entries or other things. And again, this is something that we do on device with no external training data, which is ethical. Then we have a feature in Nextcloud Mail, where we have a priority inbox, as you might know from other solutions, where we and other things, which mails might specifically be important for you and which not. Again, a machine learning model, we improved it lately, even made it more sophisticated, running on device, no mails are sent somewhere else, and so on. I don't know if everybody realizes how important and how interesting this is, because other solutions, like if you look at Hotmail or Gmail, or even some plugin that exists for other mail solutions, they all require that all your mails is on a remote server, like managed by a big company, basically, out of your control. So this is the only solution where you can keep your mail under your control and still have these innovative features. So that's something that's, again, privacy aware, completely local and ethical. Another feature we launched actually 4 weeks ago is a system where we can do document classification. So you can upload a document and we can automatically detect, this contains credit card numbers, social security numbers, bank information, other critical things. We can automatically flag then the file and say, okay, this is critical, and we can trigger certain things. For example, it cannot be shared outside your organization, or if it's shared, then it forces a watermark or other things. Again, this is something which is completely ethical. Now it gets a little bit more interesting. Because translation, that's one of my favorite topics, because basically all good translation systems that exist at the moment, like from DeepL or Google Translate or other things, are SaaS solutions. So all of them require that you send the documents to them and then you get a translation back. And that's obviously very, very critical from a privacy and security perspective. So we want to do a little bit better here. So we implemented Nextcloud Translate. How does it work? It actually has two different things. Start with the first one, is that at any place in Nextcloud, you can mark any text. That's a German text here, obviously. You can mark this sentence. You can then click on Translate. Then you get this nice dialogue where you can select in which language it should be translated. And you click on it, and it's basically inserted back into the document. So here we have two different modes. The first one is we integrate DeepL. So if you want to use DeepL for that, then this works, but it's obviously a red solution because no one knows how the DeepL source code looks like, no one knows what with the data happens, no one has the model, no one knows how the training data looks like, and so on. It's a complete black box. So this is not trustworthy. So this is red. But we want to do a little bit better, so we actually implemented our own translation system. So we have a machine learning model that runs completely on device, on your server, which is completely open source, and there no data is leaking anywhere. It happens very similar. You have some text, can be by copy and paste or just there. You select the language and translate, press the button and it's translated. So this is quite unique. If you really care with sensitive information, that's as far as I know, the only translation system in the world that really happens completely local, which then makes it a green AI system. The next topic is dictate, because maybe you want to dictate something into a document or a chat message or into an email. Again, there are some dictation systems available on the cloud, but not necessarily trustworthy. So what we can do, that in any place, like here, for example, in a chat conversation, you can press /, you get this menu here, you say you want to dictate something, and then you can automatically dictate into the chat. Or here, if it's an email, for example, if you're writing an email, you can press the button, say here, insert, text to speech, you dictate into your browser. It can even be translated on the fly if you want, and you press submit, and then you dictated the text into it. Again, this is using a machine learning model that actually comes from OpenAI, which is, surprise, surprise, it's called Whisper, because this actually it's a few years old, where they were still nice. So this is actually open source and can run on premise, which is a very nice solution, which works all over Nextcloud. Unfortunately, it's still only a yellow ethical AI system because the training data is not there. So we cannot really verify how this model is trained, but it is a freely available translation system that runs locally on device. Now we move into a little bit more cooler things. For example, image generation. Of course, you want to generate some images and work with them in Nextcloud. So there we have a system where, again, for example, here in a chat, you just press the / button, you get this menu here. You say, I want to have a picture of a bracelet with certain descriptions, I don't know, because maybe you're discussing some jewelry project, I don't know. And you press generate, and then boom, you have the picture generated and entered into your chat channel. So that's a very useful and handy feature. Unfortunately, this is using DALL-E from OpenAI, which means the data is sent to them, the result is coming back, and no one really knows what happens in the background, which unfortunately makes this an ethical red AI system. But if you want to do a little bit better, unfortunately, there are solutions for that. For example, there is Stable Diffusion, which is an open source alternative that we also integrated. And there you can also, again, do the same option, type in any requirement, and it generates it, and it inserts into the chat or any document you want to insert it. And that's, again, that's an ethical AI system, relatively. It's yellow, because the model is open source, it runs on device, the code is open source, the training data is not, unfortunately. But at least the privacy is protected here. And then last but not least, of course, there are text generation features, as you expect. For example, in a document, here you can at any time say, I want to insert a document, insert a text into the document. You have any requirement for the text you want to have, and you have the text generated and inserted directly into your document, which is like super, super handy. And this works in other places too. Here, for example, we have Nextcloud Office, which is based on LibreOffice, where you can say, hey, oops, I was too fast. No, I was too fast again. No, I want to insert something into the Office document. For example, I want to have a draft for a contract, draft an employment contract, and it's directly inserted into the document. That's obviously very handy. And it works in other places too. Let's say in Nextcloud Mail, I want to write a mail, and I want to have like a funny invitation email to my friends for my birthday party next weekend. I can do that, and it directly generates a nice email that I can just modify and send out immediately. Same in other places. For example, here in chat, you can say, hey, I want to send a nice message to my team members about a status meeting tomorrow, and it generates the message, and you can send it directly. And works in other places too. For example, here in a project management tool, I can say, write me a project plan to generate some documentation, and it automatically generates a project plan directly there. You can work with that. So this is obviously integration of ChatGPT. which is, as we all know, not an ethical AI system. Again, because it's just a web service, you send your data to it, you don't know what's happening there, the code is not available, you cannot locally run the model, you have no idea how the training data looks like, it's completely closed, but it's of course a nice productivity feature. We are working actively with other projects to work on a large language model that we can completely integrate with ethical values into Nextcloud. Luckily, there are options at the moment, and we're very positive that we in the next version or the version after that are able to have a large language model which is directly part of Nextcloud, where you can actually check what's happening in the background, and you can actually see that no data is leaking anywhere else. So this is our ethical AI system, which I think is really, really important. It's also important, like for this group here, right? I mean, if you're a student, you want to learn, you want to build something up, then it's really important that we follow our open source values, that the code is available, the data is available, and you can really innovate on it, and you can build something on top of it. This is so important. Otherwise, if you're just using a web service, then you're not really in control of anything, and you cannot really control your innovation, your new products, or your digital lives. So that's the mission of Nextcloud. To illustrate this a little bit, I created this chart here where we want to compare ourselves from a strategic level to other collaboration solutions. On the x-axis, you have the powerful and intuitive area, and then on the y-axis, you have the privacy-aware, ethical, and open source solution. So as you know, there are some solutions out there, proprietary ones, like from Microsoft, from Google, from Slack, or from Zoom and others, which are definitely quite powerful and intuitive. Unfortunately, they're not very high on the ethical or open source area. They're actually not open source at all. The good thing is that there are actually some open source alternatives. They are usually a lot better on the ethical and privacy side, but unfortunately, they're not very. And we as Nextcloud, we want to challenge that, and we want to build something that is located here, which is more powerful and privacy-aware than the others, and also super innovative on the intuitive and the innovative level. So the question is, of course, okay, great. How can you do that? Nextcloud is a small organization. How can you manage to do that? The answer here is that we use our superpower. And the superpower is our community, because we are open source. And this means we can all work together on that. Right? We are not like one small company, but we are a big international community, as you can see here in this room. And if we all work together, I think we can build something which is actually ethical and powerful in AI, but also respecting our values. Thanks a lot.
All right.
He's the CEO of Precursor, and he's best known for his work hacking the Microsoft Xbox. And he's going to talk about debugging Rust with Verilog.
Thanks. Yeah. When you don't give people a title, I guess they make one up for you. There is no Precursor org, and I'm not CEO of it, but it's fine. Yeah. Thanks for having me here. I guess to program committee. I always feel a little bit of an imposter because this is an open source software conference, and I'm like, well, what do I talk about here? As you saw, I had a little struggle setting up I had a live demo I was going to show, but then I had a video back. Anyways, long story. It's not happening, but we'll talk about it anyways. And apologize for the font mismatch because I'm now, my slides are on a computer that doesn't have the right fonts, so things are going to render weird. Anyway, so the topic of the talk is debugging Rust, actually just generic code with Verilog. If people don't know what Verilog is a language for describing hardware. It's basically in the line stupid open hardware tricks, trying to explain a little bit what open hardware is. So a lot of people, I think most people, when they hear open hardware, their reaction is like, that's cute, you know, but what do I do with it, right? I don't actually have the time to build this thing. I don't actually really care to fix it. You know, they just want the thing to be delivered at their doorstep now, and they want it cheap, right? So if you had like the option to buy a house that had the blueprints and buy a house that did not have the blueprints, it doesn't matter to most people, right? You know, the fact that you could have the source to your house doesn't move the needle for most situations. But there's some things you can do with open hardware if you're not into hardware. So one of the typical canonical things that we all, you know, jump up and down and scream about in the open hardware community is that, oh, well, you know, you can do security audits, right? There's this whole principle, Kirchhoff's principle, not to be confused with Kirchhoff's first law. Kirchhoff's principle, which is that you know, there's nothing up my sleeve. The idea that if you're going to have a security system, then disclosing the full function of how the lock works and where the tumblers are, the pins are, allows you to make an accurate assessment of the security parameters. But you know, in reality, again, this is an application that's mostly just for paranoid people and nutcases like me. So maybe a thing that's a little more relevant to more people in this room are things like Spectre mitigations. Still largely a theoretical area, but how many people here know what Spectre is in terms of a vulnerability? Okay, a few hands. I'll go over that very briefly. Basically, there's a class of attacks that can happen on your laptop, the machine you're using right now in your lap, where information about a secret computation can leak through what's called a timing side channel. Sometimes, depending on the data you're processing, the data can process very quickly, or it can take a little bit longer. If you measure the amount of time it can leak, for example, information about your password or your secret keys. The reason why that happens is because even though machines have this abstract model called the instruction set architecture, like, oh, I have an x86, or I have an ARM on an M1 or something like this, on the inside, the time it takes to execute instruction varies quite greatly, and it depends upon these tricks they play. Do we have a laser pointer or anything like this? I think is this a laser pointer here? Me and my old eyes can't see. Oh, there you go. Excellent. So like this is an example of what's called a branch predictor. So every single time you run through a piece of code, it'll go ahead and remember the last state that you took for going through a loop, and it'll generally say, well, since you went through a loop and you went this way the last loop, you're more likely to go that way than the other way, and so we'll speculate ahead and try to save you some time and guess that that's what you're going to do. That internal state becomes a problem because that's the vector for leaking the information about your key. If we had the source code for your CPU, we could actually have the compiler write provable automatic mitigations for Spectre. In other words, this whole thing about like this patch train you have every like 2 or 3 months to patch new Spectre vulnerability, this whole industry of researchers that's now employed basically finding the series of vulnerabilities could be worked around if guys like Intel and AMD would just share the source code, and then we could actually write compilers instead of having to reverse engineer this whole pipeline, right? But this is still largely a theoretical thing because no CPU that really actually matters that you're using on your lap has that available. But that's something that I think that would be interesting to most people. Another thing that you can do with open hardware, it turns out, is you can do debugging and performance profiling of code, which is something that's a little more software relevant, right? So the source code of a CPU, this is an example here of some source code, can be run and turned into this display here, which probably a lot of you aren't familiar with, but a guy like me would feel very comfortable looking at this. This is a set of waveforms that describes the state of the CPU. So we're looking at, for example, the data being fetched out of the register file, the instruction being executed at this point in time, like, for example, whether these are compressed instructions or not, legal instructions, is it a multiply, pipeline exceptions, the virtual page numbers, the state of the AXI bus on the inside. That's all visible when you run at the hardware level using this type of simulation. So it's an extremely powerful view on the inside of a computer, and you can use this to actually debug code. So just to review what the typical approaches are to debugging, You know, print statements. How many people debug by print statements here? Everybody, right? Like it's awesome. It's tried and true. Like it's like even in the most minimal setups, when you have almost nothing available, a print statement will generally work. It's interoperable. ASCII comes out. You can pipe it to a Python script. You can grep. You can automate other things. So it's awesome, right? But it's limited for debugging very complex and concurrent environments. Anyone try to print debug 2 threads running at once will see a garble of stuff emerging on their console of 2 things talking on top of each other. Not to mention the incipient performance problems of trying to talk to a 115 kilobaud UART when your CPU is running on at a gigahertz. So then you have more sophisticated stuff like, oh, we have an IDE and you're debugging, you're going line by line, you can see all the state of your Python code, wherever it is, GDB and all this sort of stuff. It's really awesome, we can have it, but then there's a question of who debugs the debugger, right? So when you come up with a new platform, it's actually a lot of work to try and instrument to bring in that the debugger. And again, even when you're in a multi-process system, these debuggers aren't a straight shot. You have to be able to attach to the right process, switch through. There's overhead that's incurred in doing that, especially when you get into things like performance profiling. So people who've done performance profiling may be familiar with this guy here, this flame graph. Basically, a call stack shows you how much time is being spent in every single call all the way out to the outer routines, and you can sort of determine very quickly which routines you should focus on optimizing. It's very powerful. It has beautiful output. But it can have artifacts due to overhead. So there's plenty of stories of people like, I put flame graph on my thing and I spent all my time optimizing and I found out that I was actually just optimizing the system call for getting flame graph to run, right? Or something like this. It's like the overhead of actually getting it to work can be a little bit tricky. So there's a kind of an art that comes around doing really good performance profiling. You have to use hardware counters, you have to use instrumented kernels, you have to go ahead and there's a whole bunch of different tricks that come into play to make sure you're actually capturing the events of interest. If you're going across system call boundaries, so you're bouncing between the kernel and the user space and you want to sort of plot that, that introduces a new layer of complexity because you're in different memory spaces, you can't correlate timestamps as easily. And then a whole bunch of other types of problems that happen when you're in concurrent spaces. So people do it all the time on really big systems. But it is, and it's not obvious how to do it, and it's not, and you have to set it up. It takes quite a bit of time. So just a quick review. So the niches that are not kind of handled particularly well by the approaches that I've overviewed are things like the early boot. So when your machine hits the reset vector and you have to debug it, how do you debug the reset vector, right? That's a very, very tricky problem. You don't have print even, you don't have other things. What do you do in that kind of case? Transitions between the user space and kernel, or machine mode and kernel. So if machines start life, with physical memory, they don't know about virtual memory, they don't know about your process space, they don't know about your kernel, wherever it is. You have to teach the machine where the programs are. You have to teach the machine where the page tables are going to be, and you have to tell it, okay, on this one magic instruction, we're going to have the program counter magically teleport from this address to this address, but everything's fine. It's totally okay. And the debugger is going to not deal with that very well, it turns out. And so then there's a whole bunch of other performance tuning things that you have to do. Like if you're going across system calls, that's very difficult. There's a whole class of performance tuning, what I call Heisenbugs. They're things that when you try to instrument them, they change. So for example, if you want to debug a cache or a translation loci buffer performance issue, just the instructions you add to go ahead and try and extract those can affect the behavior of the cache or the TLB, and you're no longer able to see it. And there's also sort of an issue with reproducibility. So if you have a regression and you found it and you think you fixed it, how do you later on know that you fixed it? So reproducibility is a thing that a lot of people don't talk about, but particularly when you're debugging things at the hardware level, you want to be able to go back and review the logs. So that the solution that I've been working with to try and get around this is simulating a full stack open hardware system. So when I say full stack, I mean not just like the CPU, but I'm talking about the memory model, the bus model, the peripherals, everything, right? So from the reset vector onwards, we're able to get basically a cycle-accurate overview of all the overhead incurred in the system. All of this gets bundled together and thrown into this magic box called a simulator. We combine it with our OS and application code as it just loads in the artifact for that. And this grinds for a while and produces a file that contains all the machine state from reset to the point of interest, right? So it's like multiple gigabytes of data, but it has everything the machine has done, all the decisions that were made up until that point. And then you can go ahead and dig through that with the waveform viewer later on. So just briefly, it sounds a little magical that we can have such a comprehensive model, but this is where the models come from. In particular, I design open hardware systems from the ground up. So for me, this is a little bit easier. I use an open source CPU core called the VexRISC-V. I have a bus, the axes, so the interconnect on the inside, or if I'm using Wishbone. It all comes for free as open source. If you're dealing with ARM or someone like this, good luck. Peripheral models, I write all my peripheral models or I borrow other people's. That's all open source. It becomes a little dicey on the memory because you have to deal with vendor models. So for example, if you are simulating SPI-ROM or something like this and you want to get cycle accurate behavior on the SPI-ROM, it turns out actually, if you go to Macronics, you can just download a Verilog model of most of the SPI parts, which is really cool. So I can actually get cycle accurate interaction with those. And then some RAM vendors will also give you abstract models of the RAM as well. And there's some decent, for standards like DRAM and stuff, there are standard models you can just pull and use for that. So you can get cycle accurate all the way down to where the code is coming from and where the RAM's coming from. The simulator itself that we have kind of been trying to use is called Verilator. It's not actually a full spec compliant Verilog simulator. It's actually more of like it can run sort of gate level models of devices. If you have something that gives you an abstract model, so it's like a behavioral model where it says, you know, if you're in the reset state, then all this section of the thing magically turns off. But they don't actually instantiate that at the level of gates. That will screw up Verilator. So there's a whole class of useful models that Verilator can't run. If you run into that, then I fall back on some very compliant simulator like Xilinx XSim, which is unfortunately closed source, but it actually can handle those models correctly. It runs quite a bit slower, but at least I can get it to run. The other problem with Verilator is, I mean, you can go to the website for Verilator. It does a great pitch for itself, so I won't pitch it for it. But the other problem with it is a real big pain in the ass to set up. It's basically transpiling your Verilog to C code, and you have to wrap it in the wrapper, and you have to throw it in this whole test framework and then run it. There's a whole set of tools to deal with that. But once you get through all of that, you get a cycle-accurate hardware model and a fast simulator. You can boot your OS entirely in simulation. So this is a log that's actually generated by not from monitoring hardware, but we're actually pulling out the machine statements and capturing them into a buffer. Takes about 5 minutes to boot, about 14 million cycles. It's about 140 milliseconds of runtime, which is enough for us to completely copy the kernel in, the user programs in, and run some useful applications in that amount of time. So it's about a 2000x slowdown over real time, right? So you're not going to go ahead and run Doom in this or something like that. I mean, you could, you just wait a long time. But it's good enough for getting into some real loader issues. So this is an example of what you can do. You can sort of visualize system call overhead. This is, again, our wonderful waveform view. Up here I have the visualization of the SRAM bus. So there's a traffic on the SRAM. Where you see the bright green, that's actually where the SRAM is active. We see it sort of dim colored. There's like no activity on the SRAM bus. So you can already get an idea of like where we're using the caches. When this bus is not active, that means the caches are actually hitting. And when this bus is active, it means we're missing on the caches a lot, right? And then we do a trick where we take the program counter and we plot it as a graph relative to the magnitude of the program counter. So this kind of spiky little graph is actually like the trajectory of the code going through the executable. Generally, it tends to go up because programs go from low to high in terms of execution. And every now and then you see these spikes that go up and down, and those spikes are to kind of library calls that tend to get glommed onto the back end of the executable at the end of the day. And we can actually trace through, like say, okay, here's a particular call to, for example, just a delay function. This is the message send. We activate a thread. We go ahead and run the user code. We go back to the kernel, so on and so forth. So we can actually see with very, very fine granularity everything that's going on through this whole transition. It is normally be really difficult to visualize, and this all happens over a period of 174 microseconds, so 117,000 machine calls. machine cycles. Another thing you can do is you can inspect like page table faults and cache misses. So this is an example of a transition right out of kernel mode into user mode code, and you can see that actually the program counter just stays flat for a long period of time. Why does it stay flat for so long? You say, oh, actually the MMU is refilling. It's doing a page table walk, grabbing the page tables out, loading it. We're pulling the instructions in here, and then finally we run the instruction there. Next one, next one, next one. Okay, cache miss. Next one, next one, next one. Cache miss. Next one, next one, and then finally we're hitting in the cache here. You can see this sort of like repeated pattern. That's we're in an inner loop that's cache hitting all the time. So you can sort of see this all coming out of the system. So in order to facilitate the usability of this, and this is where we're getting into where I wish I had, hopefully the video or the demo would have worked. We actually, I wrote a little extension to the waveform viewer where you can basically mouse over this and it'll actually browse through the assembly code real time. So you know where you are once you're looking inside of that machine code. Basically, this GTK wave is one of those really, when I was like playing around with it, it felt very homey. It's like 90s era C code. Like, you know, I remember back in the day when we didn't have like bounded arrays and structures and we just had to rely upon like naming conventions to make sure we didn't mess up. So but the great thing about C code is you can just jump in there and just instrument anything. It's like there are no rules, no problem. So I just stuck a UDP stack inside of there and just blast what the mouse over is putting out a port, and then I have a Python script listen to that port, and then go to the right line of the code at the end of the day. You can scan the QR codes and look at it. Does this? Oh, hey, look, the video plays. So this is a transition from user to kernel space, and you can see here as I mouse over and click, it's automatically going to the location in kernel code that's going. And so here's the trap code that's running. You can see it's doing all the things that you would expect in a trap, storing the registers and so on and so forth. And I'm scrolling around and just kind of zooming out and trying to get a little more on the screen here so you can see what's going on. And there you go. There's more of the trap code that's running. And the one thing I want to emphasize is you don't have to just go forward in time. You can go backwards in time. So when you find the particular artifact of interest, you can just scroll back in time and find what caused it. So a lot of times we're not running a simulation over, even though you say, oh, it takes 5 minutes to run a simulation, I spend 2 hours analyzing a trace because it's all there. I don't have to run it again. I don't have to go ahead and put in a print statement in. I don't have to go ahead and rerun it and break or something because the machine state was lost. It's all in this particular file. And so you can see here we're looking at the SATP, the process ID, whatever. So that's an idea of what the debugging experience looks like. But the interesting part is this file exists on my computer, and I was going to show a demo where I was just going to load it up and zoom back and forth in. So it's not like I have to run the program. It's just a static offline analysis. You could write other scripts and tools to go ahead and figure out what's going on from a single run. So that 2000x overhead sounds pretty awful, but when you consider what you can do with the logs at the end of the day, it's not so bad. So let's see, I'm almost done and almost on time. So this particular technique, I would say, is really useful for debugging things like bootloader issues. So there's, like I said, there's a magic event where you pivot from machine mode to virtual mode. This is super handy because the simulator itself doesn't care whether you're machine mode or virtual mode. There's no sort of controversy over where you're putting your performance counters or how they're mapped or whatever it is. You can just walk right through that transition back and forth, scroll through time and figure out what's going on. And then, you can, like I said earlier, you can go back in time, which is actually very helpful to be able to do in some certain really tricky bugs. So again, like open source hardware is cute, but it could be useful for people who are not into software. Maybe there's a reason that if you were looking at a particular CPU and if it had the RTL available to you, you can do tricks like this. So that's a difference in terms of the visibility and debuggability that you get into the system. So, hypothetically, if you had the source code for the CPU and they would give it to you, you could do things like microarchitectural side channel mitigations, but more practically, and just demonstrated right now, we can do debugging and performance profiling. So you need a full open source hardware and software stack to do that. But even if you were kind of using sham memory at the end of the day, if you're not performance profiling, you'll at least capture the instruction set correctness, and you can get through hairy bugs that way. It allows you to sort of root cause tricky bugs in a single shot. You don't have to rerun the thing over and over and keep loading it into your target hardware. you can analyze performance problems with zero overhead. So there's no instrumentation overhead. You're getting the actual performance issues played out. And you can look at stuff that's tricky, the Heisenbugs, TLB, cache state, whatever it is, and figure out what's going on without interfering with it. So that's it. I guess I'm a little bit early, but I think we're running behind, so it's probably okay. Thanks.
Well, yeah, thank you very much, Manny. Can we have our next speaker setting up? And in the meantime, anyone has questions for Bunny? And he's the CTO and co-founder of Cake DeFi. And he's going to talk about a deep dive into Bitcoin Ordinals NFT, an introduction to Zero, trustless ordinals trading protocol. Please go ahead.
Thanks. Hi, everyone. Yeah, who here has not heard of Bitcoin Ordinals? Oh, I should ask the other way around then. Who here has heard of Bitcoin Ordinals? Oh, there's a lot of hands. Who here actually own a Bitcoin Ordinal? Okay, not yet, I guess. Who here has heard of Zero protocol? Okay, I don't expect anyone because I'm gonna talk about it for the first time here because we have been working on that. I'm Yuzin Chua. I'm a CTO co-founder of Cake DeFi. I've been in the Bitcoin space since 2010. Yeah, active in the Bitcoin, Ethereum, Dash ecosystem, doing a lot of developments, building tools around that from the early days. I was lucky to be the chief architect of Sand Dollar for the CBDC in Bahamas. Still operating today. I'm no longer active in that project, but I'm still operating today. It's built on Bitcoin protocol. And I was also lucky to be presenting in FOSSASIA in 2016. It's an interesting story on that one because my topic of that talk on that one was something about uncovering government API or something. I got the police knocking on my door the next day because I was kind of like demonstrating how to reverse engineer an API from a government API, and I got a police letter on my door the next day thinking I hacked to a government server, which I did not. I was just hacking a software that's released by the government on my phone and showing the audience how to do that. There's no case in the end, but took I think about 3 months for it to be canceled. No, I didn't hack anything. But it's interesting because of this talk. Right? Yeah. So, Birthday Research, it's an R&D arm of Cake DeFi. So if anyone here is familiar with Cake DeFi, great. A few hands. Thanks. Yeah. So Cake DeFi is a blockchain platform. It's not an exchange. It allows you to grow your crypto in a very transparent and open manner. All the yields are actually coming from blockchain, from protocols. You can actually track where all the yields are coming from. So it's not like a black box model like you would see on FTX or Three Arrows. You go in there, they're gonna give you some return, but you don't know where the returns are coming from. So at Cake DeFi, everything's very open, very transparent, and you can see where all the yields coming from. And Birthday Research is actually an arm at Cake DeFi that what we do here is we contribute to open source projects primarily around the blockchain space, Bitcoin, DeFi chain, Ethereum, and now I'm going to talk about the one specific project that we have been working on that's on the Bitcoin space, on Bitcoin Ordinals specifically. Yeah, with that, moving ahead, let's talk about Bitcoin Ordinals. Yeah, so if you're not familiar with Bitcoin Ordinals, this is what it looks like on the website, ordinals.com. I'm going to get into the details on what it is. It looks a bit like NFT, and I'm going to talk a bit on what it is. So it's also made the news that it's kind of catching up right now that a lot of ordinals are taking up the block space of Bitcoin. And we have over 1 million Bitcoin ordinals right now that's floating around in the space. And if you're a Bitcoiner, you also have seen that the Bitcoin block size has gone up by many folds since about 6 months back. I mean, Ordinals has been around probably for a year now, but only about 6 months back, we kind of take off because it supports inscriptions. I'm going to talk about that later as well. Now, average Bitcoin block is about 2 megabytes, and before that, 6 months ago, it was like, that's like never over 1 megabyte. But now it's like 2 megabytes, and sometimes even at a capacity of 4 megabytes. So yeah, what are Bitcoin ordinals? Basically, what Bitcoin ordinals are, if you know what ordinals is in number theory, it's basically just ordering of things, like the first and second and third, and so on. So for those who are new to the Bitcoin space or crypto space, one Bitcoin is can be broken down into 100 million, which is 1E8 Satoshi. So the smallest unit on Bitcoin that cannot be divided further, it's known as Satoshi with a small letter s, because the big S will refer to the name. And every single Bitcoin can be divided into 8 decimal places, and there will only be 21 multiplied by 10 to the power of 6. There will be only 21 million Bitcoin ever mined ever in the lifetime of Bitcoin. Right now, I think we've mined probably 19 million right now, so only about 3 million to go. And it just the mining just gradually goes down. So what orders are basically ordering of Satoshi. So you would order from the first Satoshi ever minted or ever mined all the way to the last one that's ever been mined. So naturally, the first one is actually mined by Satoshi himself, and so on and so forth. So it's basically it's ordering of Satoshis. And so it's basically kind of a game started by the creator about how you can make Bitcoin kind of non-fungible, right? Because Bitcoin is meant to be fungible. Like the one Bitcoin that you get from John is the same as one Bitcoin you get from Alice. The same one is indistinguishable. But NFTs, or you want to make something that's interesting, you want to differentiate the Bitcoin that you get from someone from the other Bitcoin. So you have to create a rule on how, especially if you send someone else the same Bitcoin, how do you track that all the way to whoever that's holding that? So you have to have a rule. So the person that created this basically just came up with a rule that and on the Bitcoin system, there's multiple inputs and there can be multiple outputs. So how do you track that? How do you even track that where the same Bitcoin is going? So you just send kind of like an arbitrary rule. So the creator, Casey, picked a rule that says first in, first out. So if you have multiple inputs and multiple outputs, you're going to put the first one and going to match to the same output, and it's going to keep distributing all the way to the last output. So that's kind of how you track the provenance of Satoshi, or in this case, Ordinal, to kind of track it all the way from it being mined. So with the Ordinal system, you can actually see where the Bitcoin is coming from, where the Ordinal is coming from the moment that it's being minted at the first time. So if you get a Bitcoin, if you run through an Ord server, you can actually see where it was mined, who it was mined, and you can track all the provenance all the way to where you hold it. If you look at through a normal Bitcoin kind of a transaction tracking, it's not quite clear because sometimes your coin gets mingled with other inputs and sometimes it's not. You just can't make it out where it's coming from. But if you set a rule, first in, first out, you can then track all the way. So to make it more interesting, the Ordinal system came out with this idea. It's kind of like a fun idea initially. Why? Like now that we can track, we can kind of make it non-fungible. Like what more can we do with it? So the person came up with a game on just kind of creating some ideas on how to make some Bitcoin or some Satoshi more rare than the other. So like there's some mod rule. You can kind of like go to ordinals.com and read on how that's being derived. Basically, it's just arbitrarily defined on how rare Satoshi is. So you can see here, there's a mythic Satoshi. I think you can kind of guess where which one is the mythic one, the very first one, which hasn't ever been moved ever from day one. So here's so it's assigned as a mythic, and then the rest is kind of like you have some certain pattern that is gonna fit into some of these like uncommon, rare, epic, legendary. So most of the Bitcoin that you get is gonna be common, and you can also see that there's a current supply here. So 19 million has been mined. 19 million Bitcoin has been mined, multiplied by 100 million, so that's 1.9 quadrillion. kind of being split up. Even uncommon, it's kind of rare actually. If you get a Bitcoin, if you run through the system, it's very unlikely that you get an uncommon Satoshi. So yeah, it's quite interesting. So Bitcoin ordinals, it's a digital artifact. Also, it's more nerdy than the NFT counterpart on Ethereum because there's a certain rule in place where it's also the reason why ordinals community doesn't like it to be called NFT, because NFT is basically a pointer to something that's arbitrary. Like if you had an NFT on Ethereum space, it can be pointing to a real world object, it can point to your sneakers, it can point to your virtual world art piece, it can point to anything, and it's very arbitrary. The link is not real. Whereas for Bitcoin ordinals, there's very specific rule that it has to be immutable. Like if you inscribe something on a very specific Satoshi, it stays there. Like you cannot override it. I mean, just a rule is made up. So that rule is there. Like if you override something, it's not going to be valid as a Bitcoin ordinal. So no external link, content is fully on chain. So kind of split the Bitcoin community into half as well, because there are some Bitcoin maximalists who say that Bitcoin should not be used to store data, should only be used for financial transactions and do things that relate to Bitcoin itself. And right now we're using a lot of Bitcoin space to store like binary data. And the thing about Bitcoin is that it stays there forever. So if you download Bitcoin blockchain, you're going to have to download all this stuff as well. Even though, because this uses the witness layer, technically it can be purgeable, but people are not purging it just yet. And inscription is an added feature to ordinals, just so that instead of just a game on a number, on how rare a Satoshi is, so it adds this feature to attach something to that Satoshi. So it's called inscription. So you can attach image, you can attach audio, you can attach video to a certain Satoshi. So inscription is kind of like a feature to make ordinals more interesting. It was added kind of quite late, actually, like more than I think 6 months or 9 months in after ordinals was invented. And it basically can attach any binaries. It's not limited to only things that are renderable on the web. You can attach anything at all, as long as it fits at 4 megabyte space, because that's the limit of a block. And you can only fit that. And everything is fully on chain. So all the binaries are fine, but usually because you want to render that on a website, you would only attach things like text, audio, image, and movie. It's kind of you gotta convert all the binary into into ASCII, and then you're gonna attach a mine time on top, and then you're gonna put it onto the Bitcoin blockchain. So basically, this is how it is. So this on this example here, it's a text that says "Hello World." You can attach it to the Bitcoin witness space, and this goes in there. And you can see even the logic here that uses a Bitcoin script, it doesn't really do anything. These are just to attach that binary data. So what's next? So we have ordinals. We have kind of like a token. What's next that people want to do with it? You want to trade that ordinals. I think as we speak right now, there are probably about, I would say maybe 8 or 10 kind of like trading sites out there. A lot of them are very centralized. A lot of them are very you have to log in there, you have to upload your Bitcoin, you have to send them your Bitcoin, they send them your ordinals, and then you can trade on a very specific site. So what we have here today is, can we make that even more decentralized, more trustless, because that's what Bitcoin is, and also what free and open source software is, and also the reason why I got into Bitcoin in the first place, because I like OSS, and I've been working with on open source software for a while now. So trading, let's talk about trading first before I talk about marketplace. So trading, how to make trading works on a Bitcoin system. So firstly, before we talk about that, we have to introduce the concept of ordinals and cardinals. So it's a name that ordinals user came up with to differentiate between non-fungible and fungible. So the non-fungible Satoshi is known as ordinals, so everything can be tracked. Cardinals are, it can also be ordinals, but it's just basically just a way to say that these are just Bitcoin, these are just Satoshis. So just to call it cardinals. They are technically also ordinals, but they just don't have much value. Right? So the beauty of Bitcoin model, the UTXO model, the unspent transaction model, basically allows for multiple input and multiple output. So you can send, if I have, it's just like, it works exactly like a real world dollar bill. Like if you want to, you go to a stall, you go to a restaurant, you want to buy a, let's say, a drink, it costs $7. You have two $5 bill in your wallet. You can pay the person, you're gonna pay the cashier $5 and $5, and you're gonna send $7 to the restaurant. You're gonna send yourself $3 back. So that's basically how Bitcoin system works. So in this example that I just gave, a hypothetical one, I have two inputs, which is two of my $5 bills, and two outputs, which is the $7 to the restaurant and $3 back to myself, to a new address. So that works on the Bitcoin side. So on Bitcoin, we can actually make use of this very unique system to create a system where you can actually trade ordinals in a completely trustless manner without having to have intermediary to kind of facilitate that trade. So how it works is basically by owner of a ordinal becoming the taking away. The owner of the ordinal taking the Bitcoin that's been paid for, and then the buyer sending the Bitcoin over, which is the cardinal, and the buyer taking the ordinal from the original owner. So basically, just switch of an input and output, switch it around, and the owner gets the output. The owner of the ordinal gets the output of the cardinal. The owner of the cardinal gets the output of the ordinal. So it just works exactly on the Bitcoin system. So how it works a bit on the lower level side is either the buyer or seller. So someone has to do this first. So the step on how this works is the buyer or the seller could craft a partially signed transactions. So anyone in Bitcoin space, you can craft any transaction. In order for you to sign it, you need to be the actual owner. You need to have the private key to sign something. But you can craft any transactions on the Bitcoin space. So a buyer obviously going to negotiate the price first. And once you negotiate the price, you say, okay, I'm going to buy your NFT for ordinals for 1 Bitcoin, for instance. So I'm the buyer here. I'm going to craft a transaction with my actual Bitcoin with your ordinal, and I'm going to send you that transaction. I signed my part, so you haven't signed your part yet. So you're going to get a transaction which is partially signed. You're going to validate that 1 Bitcoin is true. If you accept the price, you would then sign your part of the transaction to say that, okay, I accept this transaction. I'm going to sign my part. Therefore, I'm going to send you my ordinal, and I'm going to take your 1 Bitcoin. So it just works exactly like how it is, and you don't need any intermediary to kind of facilitate all that. It's completely trustless. It's also atomic. Like if the owner of that ordinal doesn't like it, he doesn't have to sign it. Also, there's also an additional feature that can be added to make sure that that transaction actually expires, so that you have to sign it within a certain time, so that the seller doesn't have to cannot hold on to that forever and just sign it wherever he wants. So you can actually add a date as well for it to expire. So Bitcoin supports all of that. So now that works on the actual trading part, so the next thing is, the next problem that we need to solve here is that if you own a Bitcoin cardinal, how do you announce to the world that you actually want to sell, and how do you name the price that you actually want to sell? So you can go to some of those sites that was talked about earlier, that you can just list them on sale. But the problem of doing that is that some of them may require to give up ownership of your custodial of your ordinal to upload to the site. Therefore, you can trust the site to hold it for you, and you can list it for sale there. But can we make it better? Can we make it completely trustless and completely decentralized? Sure, we can. So this is what we worked on. It's called SADO protocol. The URL SADO space is still in a work. I think the website is still kind of rough right now, but I'm going to kind of explain how it works. So it uses a combination of two technology, IPFS and Bitcoin. So IPFS, if you're not familiar, stands for Interplanetary File System. It's to put it simply, it's a torrent technology behind it. So it's like a BitTorrent where you run multiple seeds, and there are seeds all around the world, and you can, if you send a certain file, it's going to jump across multiple nodes and arrive at your destination. So it's kind of like the BitTorrent technology. So how it works in this case would be the maker. So I'm going to use maker as the person that's intent to sell an ordinal. It works on both cases, even for the buyer. So I'm just going to make it simple, like the person that intends to sell will be the maker. So the seller will create a JSON order and uploads the order to an IPFS, and that gives you the CID, content ID. So that order itself will contain the signature to prove that you actually own the ordinals that you're trying to sell. So you put it onto IPFS, IPFS will give the CID. You then send it on the blockchain itself, the CID, so they get broadcasted to the world. So anyone that participates in Sado protocol will listen to the Bitcoin blockchain to see is there any broadcasting sale on the Sado protocol. So if you pick up one, you pick up the CID, which is a really, really small one, so it's not going to cost you a lot of money to put it on Bitcoin blockchain. So you pick up the CID, you can then grab the data from IPFS, do your validation to make sure that the maker actually owns the ordinal and it's still there, and the signature is valid. So the maker will actually have to sign that as well to prove that he owns that. If you see that order and you're the buyer, you're going to get the IPFS and you like the price, you will then create the partially signed transaction just like I said, upload the partially signed transaction to IPFS. So you're going to sign it on your side first, and you're going to upload the partially signed, because you cannot broadcast a partially signed transaction over the Bitcoin. Only fully signed transactions can be broadcast over the Bitcoin network. So in this case, you're going to upload a partially signed transaction to IPFS. You will then send the offer CID through the Bitcoin system. This is a separate transaction, independent from the partially signed one. So you will create another Bitcoin transaction to kind of tell the seller that here's my order and here's my partially signed transaction. If you agree to that, go to IPFS and grab the partially signed transactions, sign it on your side, on your ordinals, and then you just relay it. So you don't have to go through another round, another dance through the IPFS anymore, because now that's fully signed, the seller can just broadcast it over the Bitcoin network, and that completes the deal. So you got the full transaction on how to initially announce your intent to sell to the eventually completing the deal. So in this case, there could be also multiple offers. So if a really good piece of art that gets a lot of offers, then you can basically decide which one you want to sign. It's kind of what it looks like on the Sado protocol website. It's got a reg test right now, and it's working well. So Sado protocol is free and open source. It's self-authenticating. So Sado stands for self-authenticating decentralized ordinal book. So free and open source, self-authenticating. All signatures are validated before it can even be treated as a valid offer or a bid. And it has a default global order book, which means that any sites that utilize Sado protocol, you're going to be able to share the same order book globally, and there's no fee involved whatsoever. Everything is free. And it's also open to allow private use, that you can have your own private Sado order book if you want to. It's all completely open. So to make it more user-friendly, on Birthday Research, we're also working on another more of a front-end website to make it more user-friendly. So it's called Oddsar, or no Bazaar. It uses Sado protocol, and it's non-custodial. You don't have to upload anything. You don't have to send us your Bitcoin. It's just a viewer. You go to there, give you the string for you to sign. So non-custodial. You own your own Bitcoin. You own your own ordinals. You own your own cardinals. And the key thing about Oddsar is that the UX is going to be a little bit, for ordinals today, it's actually quite tricky compared to Ethereum, because on the Ethereum ecosystem, it's very developer-friendly. It's very decentralized app-friendly. You have MetaMask. You have a lot of tools. You have a lot of JavaScript tools for you to build. Whereas on Bitcoin, you don't have that right now. It's just kind of like just open up right now. So there's no de facto wallet. There's no default wallet. If you ask Bitcoin is what wallets that they use, you're going to get like 10 different answers. You can't even find a trend on what kind of a common Bitcoin wallet that people are using. So ordinals and support is also very, very limited on Bitcoin wallets today. So if you buy an ordinal and you don't mark it properly, because it's just like any other Bitcoin, you might accidentally send it out to someone else. If you pay like a $10,000 for a very priced ordinal, you might send out to someone else because you don't mark it to not send it out. So you have to use a wallet that you can freeze to send UTXO to not resend it, or use a Bitcoin wallet that supports ordinals. And this is how it looks like. With that, it's kind of a tight. If you want to learn more about it, go to birthday.dev and Sado.space. Thank you.
Yep, thank you very much, Hudson. And if
questions?
We'll get our next speaker set up. So in the meantime, maybe we can have one or two. Wait, that can you have? Yeah, thank you.
the one question. So why you
Go, is it? Yeah. All right. Kaylee Go, and she's going to talk, she's from GovTech Singapore. She's going to talk about open attestation and open source document endorsements and verification framework using the blockchain. Thank you very much.
Okay, hi everyone. So I'm from the GovTech Singapore. Our mission is to engineer digital government and make lives better. So today I'll be sharing on open attestation. This is an open source document endorsement and verification framework using the blockchain. So I know I'm the only thing standing in between you and probably your post-conference drinks or dinner. So I'm just gonna get straight into the meat of it. I'll just say that I think in the public consciousness, when we hear about the term blockchain, most people think about cryptocurrency, and we've definitely heard a very fascinating presentation earlier on the on Bitcoin ordinals. I'll just say that for open attestation, what we're interested in is how the key attributes of blockchain can be applied to document endorsement and verification. At the same time, there's certain limitations of the technology, but we think that the way that we're designing open attestation can help us to either get around this or to basically make it less of an issue, I think, for how we are using blockchain for open attestation. So I'm just going to get into how it works. So for open attestation, what this is an open source framework to endorse and to verify documents. We have two key components. The first, we look at verifiable documents. So these are tamper-evident documents that cryptographically prove the authenticity, the source of the document. So you can think of credentials like academic qualifications, proof of identity, proof of employment, etc. We also look at transferable records, similar to verifiable documents, but these are documents that can have an owner. Usually such documents confer ownership of assets. So we are looking at documents like title deeds or a bill of lading. What I think is interesting about open attestation, it allows for decentralized issuance of credentials. And I think we really do believe in the power of open source software. And that's why all of our code is open source. So the verification can, of course, be distributed. Anyone can set up a verifier based on our technology. But depending on the use case, we can also centralize the verification process in terms of directing people to a particular verifier. And that's just for perhaps a better user experience, or for certain government use cases, just for better public comms in terms of how to use the documents. So earlier I mentioned that a double-edged sword, or like one of the I guess, points of blockchains that the data stored is public, right? So you may be thinking, hey, you know, some of these credentials are confidential, it may be personal. So should we really be putting that on a blockchain? So what we are doing in open attestation is to design it in a way that upholds data privacy, because we're only publishing a document hash on the blockchain, but not the data itself. So I'm going to get into basically how we are doing the verification. And this is essentially premised on 3 critical steps. So when we look at the verification tech, which is the core of open attestation, we are trying to provide 3 critical steps. So the first one is to verify that the document has not been tampered with and that it has been issued by the issuer. We want to verify that the document has not been revoked, and we also want to confirm the identity of the issuer. So how does this work? When we issue an open attestation document, we first take the raw document in JSON format, and we put it through a process that we call wrapping. So the end product of this wrapping process is a unique hash that represents the document. And of course, if the document is tampered with, then it will not be possible to derive the same hash, and we can prove that it has been tampered with. So the flow is pretty simple. For each property, we salt to prevent rainbow table attacks. We then flatten and encode the properties as a string. Each field is hashed with the value and salt. And then we store all the output hashes in an array. Finally, we hash the array of hashes to produce a target hash. So I think to put it simply, it would be a hash of hashes. What this allows us to do is also to perform selective redaction on the document. So if we want to, say, redact a particular field of the credential, for example, it's not necessary to disclose this, right? And people would naturally want to minimize what they're sharing. Then it's possible to redact the particular document property by removing it from your credential and storing the hash under a different field that we call obfuscated data. However, this still does not invalidate the target hash because it doesn't invalidate the target hash of the document, because we are computing the target hash out of using all of the hashes that have been stored in the open attestation document, including those that were moved to obfuscated data. So after performing the wrapping process, this is an example of how it will look like. As you can see, the document properties have been salted, and we now have a target hash that represents our document. Okay, so now we have found a way to wrap the document. Next, we need to verify that the document was issued by the issuer. We have 2 ways of doing that. So the first one would be via a smart contract. The issuer basically deploys a smart contract that acts as what we call a document store. This keeps a record of the issued documents, the issued hashes of the documents. But do note that this involves an on-chain transaction and does consume gas. But we'll come back to this later. So this allows anyone to check if a hash, which represents a document, has been issued. And then when we are during the verification process, what we are doing is to first check that the target hash of the document is in the document store's list of issued hashes. And we are also checking that it has not been revoked, that it is not in the list of revoked hashes. So I would say this was probably the first iteration or the first version of open attestation. Another newer method that we developed would be to use decentralized identifiers to issue documents. And currently we're using DID Ethereum. So after signing the open attestation document, basically it would contain the issuer's DID and the signed target hash. Then when we are doing the verification process, what we do is to compare the Ethereum address from the DID document with the address that is returned by verification. If it matches, we know that the signature is valid, the document has been issued, and that it has not been tampered with. Okay, so earlier I did mention that issuance does consume gas, and this can potentially be an issue for users if you're issuing documents one by one and you have many documents to issue. So what we also developed is to allow issuers to batch transactions using Merkle trees. So each document target hash is a leaf in the Merkle tree, and we compute the Merkle root, which is then stored in the open attestation document, along with the proofs needed to ensure that this document is part of this Merkle tree. Of course, for a single document that doesn't need to be batched, then the target hash and the Merkle root are the same. All right, the final area or step of verification would be on the issuer identity. This is I guess it's still an area that we are still working on and developing. Currently, we leverage on the domain name system. We use the DNS text records to publish the document store address or the DID. And then this is then checked against so that we know that the credential is issued by the entity that controls this domain. Okay, so now I'm going to get into the perhaps more exciting part of my presentation, which is to talk about the products that are currently powered by open attestation. And this is by no means an exhaustive list, and we are always looking out for more ways that the open attestation can be applied. And so that's partially why we're here today at FOSS Asia. I'm really interested to hear if there's any ideas for how this technology could be applied. So the first one I will talk about is called Open Certs. Basically, it started as a proof of concept to improve productivity. Basically, schools were spending a lot of time and effort on verification of the certificates. So you'd have people, maybe employers, who want to confirm that the graduates' paper certificates were legitimate. So they might say, call up the school and ask the school to check and verify. Schools were also spending time on replacement of lost certificates. So this was consuming, I think, up to at least 7 man-months in a year. So with open attestation, which powers open certs, so graduates from Singapore Institutes of Higher Learning can receive their degrees or certs in the form of an open attestation document, and then these can be easily verified by employers on the opencerts.io verifier. Yeah, I'm not sure if we are able to open the link here or whether I'm able to switch out to a browser. Okay. Mm-mm. Yeah.
Yeah, it's you.
Oh, great. Fantastic. Yep. So this is the Open Certs verifier. So if we look at the demo, this is how the user would go through it. They would, you can just easily drag and drop your cert into the verifier. This will load up our decentralized renderer. It will render the cert, for example, we have this demo, and there can be multiple views of the same open attestation document. Another thing is, earlier I mentioned that we allow for selective redaction of credentials. So for example, we are able to, say, redact certain info that's not required. So for example, if you're only focusing on the CS course, on the CS courses and the grades, you can redact, let me grab this. So you can redact the details and download the file, but it will still remain verifiable. Yep. And then you're able to download it. And if I try to verify it again, okay, maybe a bit. Downloads. Oh, downloads. I see it. Thanks. Yep. So if we verify it again, you can see that the redacted fields have now been removed. But we also do mention that it has been redacted, just not what was redacted. And earlier, when we were going through the verification steps, this is how we would provide the assurance to verifiers in terms of it has not been tampered with, it's not been revoked, and it is issued by, say, this particular entity, in this case, GovTech. Yep. Okay. So that's one of the, I think, first use cases of open attestation. The next one is a bit more recent. So if I'm just going to toggle back to, sorry, and click here. Okay. Yeah, so this is probably a bit more recent. So during the COVID-19 pandemic, it was really important to be able to prove that vaccine certs and test results were legitimate. Also to eliminate the existence of fake COVID-19 test results, and also to support the opening of borders and resumption of life as normal. So given the decentralized nature of the issuance and the need for a way to attest to the documents in a cross-border way, so open attestation was adopted as a solution, and this powers the health certs that basically Singaporeans use to prove that they have been vaccinated, for example, or that they have passed like their pre-departure COVID tests. So users could go to this notarized platform to apply for a notarized health cert for travel, and then cross-border, immigration authorities could easily scan the QR code of a health cert to verify it. So I'm sharing this example because I think it also shows the strength of the free and open source movement. Because OA was open source, because it had been used for other applications, there were providers out there that were able to help perhaps less tech-savvy medical clinics to onboard the health cert solution, and for them to quickly issue vaccine certs in the open attestation format. So we were able to adopt this solution quite quickly, and I guess in a scalable way. And the last use case that I'm excited to share about is called Trade Trust. So I'm the product manager for Trade Trust. We are basically looking to accelerate the transformation from paper-based trade documents to digital documents. When we look at the current state of cross-border trade today, it's largely paper-based. One shipment can involve many parties across different sectors, many exchanges of information, many siloed systems, and this is very inefficient and costly. At the same time, when you have manual handling, it can be vulnerable to fraud. I can take the same document and use it to take out 2 different loans from 2 different banks who are none the wiser. So Trade Trust is a framework to accelerate this this transformation. And we look at it in 2 ways. So for trade, we have verifiable documents. So these are perhaps things like an invoice or a certificate of origin that tells me, okay, this shipment comes from this country, is eligible for certain preferential tariffs, for example. The second is to find a way to allow electronic bills of lading to be transferred between parties along the supply chain. So a bit of background, what is a bill of lading? In trade financing and international trade, the bill of lading acts as a receipt of goods, and anyone in possession of this bill of lading can claim the goods at the destination port. So for example, in this case, if I'm trying to sell something to someone in a different country, I might enlist a carrier or a ship to help me transport it to them. The carrier will issue me a bill of lading. I'll then courier this bill of lading to the buyer, and the buyer can produce this bill of lading at the destination port to claim the shipment. So this is really a very simplified version of how this flow works in international trade and trade financing. But sometimes it's not as smooth, because you can imagine sometimes the bill of lading will go through multiple parties who are financing this trade. So it's even possible that by the time the cargo arrives at the destination port, the bill of lading is still being couriered around the world, and the cargo is just sitting in the port waiting to be released. So I think that's where we see a lot of potential for electronic bills of lading, because the transactions can be conducted on a chain, it can be really fast and instant. So what we do in trade trust is that we represent the bill of lading as a non-fungible token. We bind the NFT to what we call a title escrow smart contract, which then controls changes to the ownership of the token, as well as who is allowed to change the ownership status of the token. And this setup mimics the current process for paper-based documents in terms of who is allowed to change the holder and the owner of the bill of lading. Yep, so I hope I've given a brief overview of how open attestation works. What are some of the use cases that we've applied it to currently? And here's how you can get started with open attestation. Can learn more about our framework over here. Please come to our GitHub and explore our code. Feel free to open issues with us and talk to us. And I'm really happy to take questions and to figure out what other use cases we can have for this technology. So yeah, thanks everyone.
Thank you very much, Kali. All right. We got Ben.
Thank you. Great project here. I love it. Question on the bill of lading example you just gave. So the bill itself is issued as an NFT, and it's verified using the open attestation smart contracts, right? So two contracts involved in this use case.
It's not verified with the open attestation smart contract, but it is verified with the open attestation signature and proof method. Right, so I guess it uses the same cryptography that takes the document and digests it into a target hash, and then we're using the NFT to deal with the transactions.
And regarding the use cases you mentioned, which chain are they using? Which EVM chain? Are any of them actually using Ethereum, as that's quite costly? Just wondering if any of them have adopted a sidechain or L2.
Yeah. So for our users, they're using Ethereum as well as Polygon. Yeah.
Thank you.
Roland.
I had a question on the rationale for the use of a blockchain in the first place. Given that, at least for the examples you gave, the person relying on the credential, the employer or whatever it is who's trying to evaluate the validity of the credential, is relying on both the signer having a working revocation function. If there's no working revocation function, then there's no way to know whether fraudulent certificates have been issued and not cancelled. So the organization has to exist, it has to have a working revocation function. And further, that you're using the DNS to deliver the authenticator, the public key that's used to validate the signature. That's a real-time service dependency. It's a technical service that has to be working in real time. I'm wondering what value there is in using a blockchain at all versus a more conventional web service. Because there must be an organization, it must be responsible, and it must have real-time services available, otherwise your mechanism won't work. So what have you gained by using a blockchain at all?
Okay, going to your first question was on there being a way for the issuer, the signer, to hash the document, right? And this should be...
Well, let me sort of make the counterpoint. If you rely upon the organization having the ability to revoke, then I would suggest that a blockchain is useless. If you rely on the organization presenting a service that's available to you in real time, then a blockchain is useless. Blockchains are only useful, I would suggest, if both of those things are false. In this case, both of them are true. Why would I use a blockchain? Why wouldn't I just ask your web server to tell me that this certificate is or isn't valid?
Yeah. A few things. I think when it came to this situation of, for example, if you're looking at academic certifications, I think what ended up being the case was that verifiers would want to go to, say, the Ministry of Education and ask them to verify, for example, these documents, and that was assessed to take quite a lot of manpower, a lot of efforts. So the idea of this was, is there a way to...
No, I understand why, sorry, we should probably take this offline. I understand why take away the human process. I'm asking why use a blockchain. It seems to me it would be simpler and more reliable to use a web service. Because there's same. It's DNS. You've got a real-time service. If it's down, you're out. So you want partitioning or availability? Then you haven't got, yeah, okay, let's take offline. It is a Capt-theorem problem, yes, but I don't think it's also.
Yeah, and I think we acknowledge that. I think DNS is probably not the best way to look at the issuance, and
all possible, I would argue all possible mechanisms have the same problem. There's no way to escape this. Anyway, this is an offline discussion.
All right, any more questions? Yeah, one more from Harish up there. Gonna make me go up the stairs, so thank you. Yeah. This guy. Next time, sit down there, huh?
I got a question about how do you, when you have the cert issued by an institution, what if the institution merges with something else? How do you ensure that these things are sustainable, 100 years from today? What is the mechanism for something like that? I mean, including the DNS portion, right? I mean, where there's a lot of dependency that requires that this entity exists, that, there's a way for me, whereas a piece of paper is a piece of paper, yeah, I mean, I can fake it, but yeah, it's still a piece of paper. So I hear, this is something which I've been struggling with, trying to find out how does this even make sense from a sustainability perspective. Thanks.
So I would say that in the situation where maybe the institution merges or maybe they move to a different domain, I mean, the document store, so the smart contract on the blockchain would remain, and it might just be a matter of linking that document store to the new domain, for example. So that's, I think, maybe one way to address that. Yeah. Also, I suppose if, for example, you have institutions merging, I don't think that would invalidate or it should not invalidate any certificates that were issued by the old entity. And operationally, they may not want to reissue the certs under the new name because it was issued at a time when that institution was a different entity. So I guess with the immutability of the blockchain, that's one way to ensure that even after the entity has maybe closed down or moved on, the records would still be there. Although, admittedly, we would need to find a different way of tying the issue identity to the document store on the blockchain. Yeah.
Yeah, just to add on to the answer to his questions, like if you guys ever, in the early days of doing cryptography, if you guys ever went to signing parties and X509 certificates and dealt with all the complexities of that, compared with the ubiquity that Ethereum and these things offer today, it's just night and day difference from a practical basis. From a theoretical basis, yes, it's not perfect, it doesn't do everything, but from a practical perspective, it's just so much easier to use, and it's just common how everyone is used to using it. My question was, so I was kind of surprised that, I thought you were describing that this was just a protocol, but in fact, you guys have actually developed and released software. What is the scope of that software? Like if I'm an organization and I want to be able to do verification of my own documents and stuff, is that what this is on? Is that what this is going to provide?
Also, I guess what I would call these reference implementations. And we also do release the code for that as well. So for example, for TradeTrust.io, the verifier is open source, and implementers can refer to that to spin up their own verifiers and to use our CLI to help users to issue documents. Yeah, so there's the underlying framework. It's also the applications that we've built on top of that. And to the best extent possible, we do try and make it open source.
This is very forward-thinking stuff for you guys in Singapore, so I hope it catches on. Outstanding.
All right, we got more questions there.
So I was curious, when you did your research on how to implement this, if blockchain was a winner, which was number 2 option that you rejected?
Okay, so I think the two, well, one question that we do get asked is why not just use DocuSign or a similar, say like signing a PKI-based digital signature that you can easily open a PDF, and you can also have that sort of I suppose verification that hasn't been tampered with and that was issued by a certain entity. I think the two benefits of open attestation would be in terms of revocation. It's a lot easier to revoke as opposed to trying to revoke the signature of a digital document that you've already signed a PDF and sent out. And the second one, which I think has a lot of potential, maybe hasn't been realized yet, is that I mean the open attestation files, it's in JSON format. I think it's more machine readable as opposed to like a PDF, a DocuSigned PDF, for example, that is maybe harder to integrate with systems. So I guess that was one of the other options that we considered and eventually decided not to go ahead with.
Right. Hey. Hi. Yeah, I don't really have a question. I just want to add a bit of color to this great presentation. And I actually happen to work with the protocol a bit because I was working on a software that actually utilizes this. It's called NextID, and it utilizes this. Is actually really, really great. And also, I just want to add a bit to Roland's question just now on that there's no need for a blockchain, which I actually agree in this case because it's basically just everything's just a Merkle tree. So you need to, it just ties into the Merkle root because all the certs are actually not published on chain. It's basically every cert has a hash that's hashed to that, and then you just build that tree, and then you just have the root that you refer to somewhere. So you can see that on the DNS, or you can actually see that on the blockchain itself. But blockchain itself is actually not used in this case, but there's one fundamental of blockchain that's actually adding some value here, which is the immutability part. So it helps when a cert is, let's say that seed is changed someday through DNS, and you cannot see that it is changed. So the blockchain part actually adds that seed or that root is changed. So you can actually see that it is changed. So everything else is just cryptography, just PKI. So there's no need for blockchain or smart contracts, but that blockchain part actually helps to make sure that it is unchanged, and you can actually track that it is changed or it's being added and all that. Correct me if I'm wrong. It's something I want to add there. Thanks.
All right, thank you very much. And I think with that, we close our session today. Thank you very much, Kylie. I will give you a round of applause. Thanks for taking the time.
Yeah,
and all
thanks
the
everyone.
questions.
And I think just responding to what Yusin mentioned, I think we don't see it as just a pure blockchain thing. I think it's wider than that. If we look at verifiable credentials, and that's not something that is necessarily tied strictly to blockchain. And I think we're also interested in seeing perhaps what are the different links and between the different ecosystems now.
All right, yeah, thank you very much. And yeah, thank you very much, guys. With this, we're going